What's up, what's up, what's up? I started the day working on my typing skills, trying to type faster, and the fastest I've gone is 52 words per minute. That's it. That's it. That's all I got.
Music management, video
Okay.
production,
So,
industry.
last time I was learning how to define a function within a scope. I already know how to do this. We actually learned this in my first video when I was using the boot.dev program over here. But I'm using this program because a lot of people talk about it, and it may possibly be more valuable to people, I guess, because boot.dev is new, whatever. So I still want to do boot.dev, but I'm probably going to focus on this one more. Just because it seems like people appreciate this one more because it comes from a university or whatever, MIT, a tech thing, whatever. Check. Yep. Calling functions and scope. I think I already know this, but
program scope when I print
I'm
out
gonna go ahead and see what this guy says.
Okay. I'm going to show you one more example of scoping.
This dude like reminds me of somebody. Like he reminds me of somebody. Like I feel like I had a teacher that looked exactly like him. You know what I mean?
He does
Like-
have that.
You know what I mean? Like I feel like I get this weird like deja vu feeling. Like I feel like he's been teaching me all my life throughout school or something. He's just been popping in and out every couple of years.
I want to do a quick aside which says when you get to really tricky things, there's a nice place to go look, which is this place on the web called the Python Tutor that helps you sort these pieces out.
Oh, that's cool.
In the last example, before we move on to other...
Hold up.
I want to share
Let me go ahead and save this little Python tutor. Is that what he said? PythonTutor.com. Ask your question. Your code visualization will be sent.
the errors.
Compiler, AI tutor, and visual debugger. See, I already technically have this, so I don't really need this, because if you go to Visual Studio, which is the one I've been using, other than the one they got me using, that other spider one. But if you use like Visual Studio, from Visual Studio you can actually use a AI thing here. Let's see if I can... Or even like Python, they have Python debuggers right here. So no problemo. There's Python, but I already have Python. I got Python, I got JavaScript. Yep. I mean, I'm working on it. I'm trying to get somewhere with it. Yep. Okay. 10.4. And then, oh yeah, I need to open the Spider app actually, because that's the one that they got me using. And the Spider app has a debugger too, so I don't really know why we're using Spider instead of Visual Studio Code.
See, it won't even let me do that.
This is what Spider looks like. And literally, like, I mean, I can type stuff in here, and if there's a problem and I'm not doing something right, like, which game? What do you mean, which game?
What?
I'm not playing a game. What?
Me?
I don't know. Someone said which game.
No. He's learning coding.
We're learning coding. This is Python. But as I believe you can make games with Python. The only thing that I made was like this little thing, and it's basically like, so like you hit the play button, and then you press enter, and you know, this font's really small. You're probably not even gonna be able to see this. Hold on, let me open it with Visual Studio Code. Wait, where was it? No folders opened.
You require our to sponsor you to obtain.
File, open. Oh, let's do open folder. And then, where was? Oh my god! Did I exit out Spider? Oh my god, I did, didn't I?
What is my desired salary range? I don't know. What is
Well, you need to.
on-air personalities? What do they get paid?
You want me to look it up?
I guess I could look it up. You're doing something. Sorry, that's my bad. I'm not asking you, and you're in the middle of something.
Oh, it's a radio host, right?
Minimum.
Mommy,
Yeah.
it broke.
It broke.
Yeah.
That's okay. Now you have 2 crayons.
Oh my god, I hate Yahoo. I don't know why it keeps using Yahoo.
Do you need diaper?
Says they national average 37 to 55,000, while median pay is around 45,000.
37. So 37,000,
37,000 is the lowest.
which is regional. It's 22 an hour. Is that $20 an
I mean,
hour?
you're sitting down and talking.
Oh, I could
and
talk.
You
bro.
make morning. Morning radio personality in Austin, Texas, 102,000. Radio talk show host is 52,000. Entry level radio host is 48,000. Oh, that's in California.
Radio talk show host in Austin is 52,000.
Yeah.
Is it starting? What is your desired salary rate? So what would 40,000 an hour be? Hourly rate.
Hourly, I would guess it's $22 an hour, right?
Because if it's 52, 22 an hour.
What'd you say, 40?
40,000. I'm trying to
40.
shoot low, because if I could become a radio host, that'd be freaking cool, man. Add that to my resume.
Into. Oh, dude, I hate fucking Yahoo. Why does it keep using Yahoo, bro? God dang, Yahoo
It was
sucks.
reset.
Okay, yep. Hourly, if, yeah.
$20 isn't much to ask for, then.
Approximately 1923 per hour.
Damn.
This is based on a standard full-time 40-hour work week, so that's if you're working 40 hours a week.
Okay.
There's no guarantee that you're going to be working 40 hours a week.
So $20 an hour ain't bad to ask for?
I guess not. Let's see. Okay. I was going to do something before I got rudely interrupted.
I love you.
Let's see. God dang it, where'd it go? I need like a separate folder for this stuff. Like, let's do. I need to create. Let's create a folder. New folder. Python. Right. Yes. Okay, and then we're gonna start putting these. Okay, let's do.
Oh.
Booger.
You need diaper? Okay. Still in your cup.
Yeah, that's fine. Okay, so now that I have these, let's see if I can open this. Open with Visual Studio. Where's Visual Studio? Come on, bro.
Self-identity crisis. What's today's date? Oh, wow, it's already the end of January. It's wild.
Alright. Now if I run this code, press enter. Wait, hold on. Boom, boom, boom. Is this even visible yet? Hold on. Okay. So I press enter. Oh, it's a read only. God dang it. I'm not using the right code. Python. There we go. Python file. There we go. Okay, press enter. Does Anthony have name? Yes. State desired name. Michelle. Hello, Michelle. Verifying access to personification data log. Enter your birth month year. I'll put 3. 3 is current life status within simulation. Bad news. Error. What is the last digit of your birth year? Oh, I'm gonna put 8, whatever. A hacker has targeted you. Will you attack or will you run? I'm gonna run. The odds of life favor you, Michelle. You escaped safely. Like a little simulation thing, no big deal. There's different outcomes, but I made that. And that's about it. I'm back to what I was doing now. Almost spider over here. Oh, wait, what? No. Yes. Alright, okay, I want to do this. I'm going to get out of here. Switch to this one. And then... Right. Okay. There, now I can start using other stuff. Okay. Oh, this is my number guessing game. Okay, check this one out. Okay. Please think of a number between 0 and 100. Is your secret number 50? Enter H to indicate the guess is too high. Enter L to indicate the guess is too low. Enter C to indicate I guessed correctly.
H.
Is your secret number 25? Is that too high? Low? Hello? Is your secret number 37?
H.
H. Is your secret number 31?
H.
Is your secret number 28?
L.
Is your secret number 29?
L.
Is your secret number 30?
Whatever yes is.
C for correct. Game over. Your secret number was 30. Oh, they put 99. Let me see. It'll guess any number. If it's 99, then you just is your secret number 50? That's too low. 75, too low. 87, too low. 93, too low. 96, too low. 98, too low. And then 99. And then you put correct. But if, just in case, you don't put what it says to put, like I don't put C, and I put like enter, it'll say sorry, I did not understand you, and then it'll repeat itself. Pretty neato. Not too bad.
That would be cool if I get this job.
Number guessing. Yep. Okay, anyways. I gotta get back to my seriousness.
And if I did, my dad would laugh. Because I've been on the radio before.
But he was only on the radio in the military, right?
Mm-hmm.
So he never did radio outside the military. What did he do when he got out of the military, or did he just do that? That was it.
No, he did all sorts of.
Did he got like normal jobs?
What if I became a meteorologist?
That sounds like you have to go to college and have
No, I
like
just got to be able to read a frickin' whatever they put up on the fucking thing.
You just gotta ask AI, honestly.
Honestly.
Just have to say every job's gonna be like that. I feel like at one point in time, or that there won't be no jobs. Okay. Scope details. Scope is so this is defining a function. You can create a function, and
Topics is to look at something that actually has a function defined inside another function. Wow, that sounds neat. Here I've got a definition for G, and inside of there I've got a definition for H. And if I look at this code, I'm going to actually run it over here. Let's see what happens when I run it, and let's see why it does.
Okay, hold up. Before he runs it, I'm gonna guess. X equals 3. Z equals G X. Okay, so X is gonna get input to X. Oh, there's a definition within a definition. I've never tried that before. Okay, so the X is gonna equal 3, but X equals ABC and definition H, but it didn't call it definition H. He only called definition G. But no, wait, there's H. H is on the bottom. So you call definition G, which is also going to call definition H once it gets to this point of the call. So this is going to take it back. So this is going to take it back up here. This is going to take it back up here. And this is going to be like X equals 3. But no, we got to do the H first. So X equals ABC. Then X equals X plus 1. But you can't do ABC and then you can't plus 1 to ABC. I don't know what that would do. Anyways, and then you put prints in G that stuff, and then the X, the remainder of X is gonna be, I guess, I don't even know what it would be at that point, but. So confusing. And then it's going to return X. What is going to be the results of that? Well, if you put... God dang it. If you put... X equals... I'm going to say the string of... God dang it, I hit the enter button on accident. X... ABC, right? And then you also put X equals X plus 1. It's an error. You can't do that to an integer. I didn't think you could. That's what it's saying. It's saying error. It's going to give you an error because you cannot add ABC to an integer. It doesn't know.
That appropriate thing.
What? He got 4? How did he get 4? It has the ABC thing right here and it calls it. Well, the first thing that's going to happen is this. So X is going to be an integer. It's going to be 4. And then it's going to print that. And then it's going to return. And then it's going to do this function. Which is going to say X equals ABC after all this. But that's an error. And then it's going to return X. So what's really going on here? Are you okay?
Mm-hmm.
Just breathing?
Mm-hmm.
You're breathing loud.
I love you.
Love you too. Okay. I wanna run this. Hold on. Give me a second to run this goddamn thing here. Cause this is okay. X equals ABC, right. X equals X
I'm glad I'm doing this because I'm finding so many other job opportunities that I didn't even consider as an option.
Well, we live. I mean, where we live is opportunity. So. Woo! All right, that's all. What is this? Oh. Print. It does do that. And why does it do that? Local variable x is assigned to but never used. Oh, there's nothing within the parentheses. I'm an idiot! There's no input to h, so it's just saying... Well, no, it was that would still mean x equals ABC, but x is only existing within that function, within that scope, so it means nothing. This means nothing. That's basically what that is. Well, I had to think about it there for a second, but yeah. All right, it's fine.
And when I ran it, it prints out the statement inside g of x, x is bound to 4. And I want to see how that comes about. So here we go. When I evaluate, or when I just in fact evaluated inside my machine this description, here's what happened. As I saw before, in the global environment, G was bound to a bunch of code. Where's H? Hasn't happened yet. It's simply sitting in a chunk of code. We have not yet evaluated that body, so nothing has happened yet. X is bound to 3. So when I get to the point shown by the arrow here, this point in the code, I've got G as some code, and I've got X bound to the value of 3. Now I'm ready to do a binding for Z to be a call to G. We saw what happened before. G creates a new scope, and inside of that scope, I'm going to bind the value of X, and that X is coming from the formal parameter for G. The value is coming from the binding for X in the global scope. So X is bound to 3. And then I'm going to evaluate the body of G. And this is cool, because that says inside of here, I'm evaluating the definition of H. This is sometimes called an internal or helper function because it belongs only to G. The binding for H right here is to some set of code. Only when I'm inside of G can I use H. It's protected. That's great. Haven't used it yet. I've just got a binding for H. And then what do? I create a binding for X, and notice what happened. I say get the current value of X, which was 3, add 1 to it, 4. And then change the binding for X in the scope of G, because that's where I'm doing the work. So it's changed that binding for X, but not this one over here, which is still 3.
Then you're gonna print.
And then I do the print statement, which is why it says in G of X, X has got the value 4, because in fact I see this value of X over here. All right, almost done. Now I'm going to call H. H is a function. It's right there. And since I'm invoking it, I create a new scope. And this scope inherits from G, which inherited from the global scope. Inside of H, I bind any formal parameters. There aren't any. What do? I evaluate the body of H. So I bind X to the string ABC. And then,
nothing.
what do I return?
Nothing.
Oh yeah, nothing, because I have no return statement. So having done that binding for X, I'm done with the call to H, and there is nothing to return. Having done that, I'm now ready to do the last part of G, which was to return X.
Wait a second. If I did return X, would it change anything? I mean, honestly. Let's say I do return X, right? What will that do? Nothing. That's what I thought. It wouldn't do anything anyways because X is only living within the definition of this. Now, if I wanted to, I could put print X, right? What is this? Oh, excellent, put that. If I wanted to, I could put print X. Now that'll print ABC. Yep. But, other than that, because I don't have any other function in here, this X is only associated within the definition of H. So, even if I put a return on it, don't mean nothing. I can even put like X. What is X? X is still 3. You know why X is still 3? Because X only becomes 4 within this function. But it still holds the same value as 3 on the outside.
I'ma get it. 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 I'ma get it.
Jesus.
And you notice that binding inside of H of X equally.
What?
No, not the audio file. It's so good.
The ABC is gone. It's been garbage collected. And so I now simply return the value of X, which I know is defined inside the scope of G, and that gets returned as the value that I associate with Z. Perfect. I'm now set because Z has the binding 4. So there's a more complicated example, but you notice how those rules for scopes very nicely tell me, and more importantly tell Python, exactly how to look up values and how to use those to store new values as I do bindings.
10-4. They took away the discount. Well, what do we have here? You have the following function definitions. Return X plus 1. Okay, what are we getting at? Below is below is the transcript decision of Python shell. Provide the type of value of the expression being evaluated. If evaluating an expression would cause an error, select none type and write error in the box. If the value of the expression is a function, select the function as the type and write the function in the box. Okay, so we have all of these definitions, and then we're going to call these definitions down there. So it's just asking, okay. So definition A is X. X is a variable, saying X integer or float. So if you enter integer or float, return X plus 1. So if you put 6, then it'll return 7. 7, it is a integer. That's going to be a float. And that is going to be, it's going to be, actually, it should be 4.3 negative. It's, oh God, what is that? A 6. What? I don't even know what that would do. I haven't tried this. Hold on. If you put, for the love of God, if you put that's crazy. You know what? Hold on. Let me think. The number only changes within the function, right? Now, what? Dude, I don't even know. I'm trying to figure this out without, like, checking, but, like, this sounds kind of... Alright, let's do this. Okay, if we put G, how many did that even do? It was like 3, yeah. But 6. Let's see. It says 3. What'll be the return on that? Does this not call the function at all then? Hold up.
I thought I had it first, and now I don't even know how I feel about it.
Feel about what?
You're listening to Nexus Rose Radio 33.3. Stay tuned, and we'll have some more ear candy coming your way. How's that sound? Radio voice. It doesn't sound like I'm trying to seduce the crowd.
A little bit. You're just supposed to talk casually.
You're listening to Nexus Rose Radio 33.3. Stay tuned, and we'll have some more ear candy coming your way. The pause is what's fucking me up.
I mean, that's fine too.
You're listening to Nexus Rose Radio at 33.3. Stay tuned, and we'll have some more ear candy coming your way. I feel like that one was better. You're listening to Nexus Rose Radio at 33.3. Stay tuned, and we'll have some more ear candy coming your way. Yeah?
Yeah.
Alright. The thing was asking for an audio bite.
Oh. They need to hear what you sound like. Yo, this is crazy. Hold on. Man, I'm just gonna, cause this is. I just gotta see what this crap does, cause this is kind of tripping me out right now. Okay, hold on. Ran the file.
Maybe start over.
It did?
I don't have the audio file.
Okay, I got a return of 7 like I thought. A. -5.3. -4.3 like I thought. Okay. A. 6. Oh, it returned 9. 6. So wait, it did run it through 3 times. I didn't think it would do that. Oh, this is interesting. So if you can do it like that and it'll run it through 3 times. Holy crap. It's like a ×3. Oh my goodness. That's pretty wild. Pretty wild. Okay, so C within A1. Okay. Oh, Jesus. Let's go ahead and pull this back up so I can see it. Okay, C. Within. So it's gonna be the A1 first, right? A, then X equals 2. Within C, and then C is, oh my god. Return x plus y. Okay, well, we're only dealing with one digit, so that doesn't really work there. Oh, you know what? This really doesn't work because it's two parentheses here, one parenthesis. Oh. Okay, so this is the x, this is the y. This whole thing's part of C. Okay, so A is 2, B is 2, and then 2 plus 2 is 4, but it's going to be a float because the 2.0 float. Yas. Yas. Okay. Okay. D, okay, right here, Apple, and 11.1 is Apple greater than 11.1. What is this going to say? It's probably going to say error, or it could be false. I'm going to say error. Okay. Holy Jesus. Okay, E within the confines of all this. Okay, E, blah, blah, blah. Okay. A3, that's going to be 4. B4, that's going to be 5.0. C3 and 4, what was C again? The add them together, so 4, 5, 6, 7. So it's going to be, what I say? It's going to be 4, and it's going to be 5.0. It's going to be 7. 4, 5, and 7 into E, which E returns both of those, x greater or equal to y. Is x greater or equal to y? No. It's less than. So that's going to be false, but it says and x is less or equal to z. Okay. X is less than c. I mean, set. But it says and, so it's going to be false because the first result. So we're going to say a boolean when I say false, because true or false is always capital in the beginning for some reason. F. If you put in F, what is F? It's not going to do anything. None type. None type. None. I got all of them right except this one. What am I supposed to put here? It's not an error. It's just none. Like it's nothing happens there. Like nothing. What the? Just like nothing happens. That's the thing. It's just if you put F, nothing function main like.
Is kilobytes bigger than megabytes?
Huh?
Is kilobytes bigger than megabytes?
No.
Then why won't it upload?
Maybe someone learning. You're connected to the internet?
Yes.
What? I mean, it should be working. Estimated time to complete 8 minutes. 8 points possible, graded. Note that you will have to answer all questions before you can click the check button. Below is a transcript of a session with the Python shell provide the type and value of the expressions being evaluated. If evaluating an expression would cause an error, select none type and write error in the box. If the result of the function, select function and write function in the box. What I should have done last time. As always, try to do this problem by hand before turning it into your interpreter. Assume the following definitions have been made. Define a okay. So what we're gonna do, we're gonna go ahead and highlight it, put it in my interpreter. That way, when I'm ready, it'll be swift and also so I can see. A, okay, A, gonna be false 2 3. A, false 2 3. If X, what? Return Y, else return Z. If X is what? If X is nothing. You didn't get it. What? It just says if X. Oh, if false. Return Y, else return Z. I feel like it's just gonna return Z, and Z would be 3. So I think if I'm very, I don't know.
Presentation deck.
Huh?
Presentation deck.
Presentation deck. I don't know what you're saying.
I don't know. It won't. It says upload your resume. I tried, but it won't let me.
Can you do it on your computer? Unless it's the wrong file type. Is it a PDF file?
Oh, PDF file, yeah. But on Adobe Scan. And then it's kilobytes. So
No, yeah, no, I mean it's.
So it's got, but it's a max of 5 megabytes.
Oh, yeah.
So I should be able to fucking upload it, right?
Yeah.
But it won't let me.
Yeah. A megabyte is 1,000 kilobytes. So 5 megabytes would be 5,000 kilobytes. Did it take it?
Mm-hmm. The recommendation.
B is 3 and 2. QR. Okay. Return A. Oh my god. Are you for real? Jesus. Okay. B is 3 2. Then. God, that's complicating. Okay, so QR is. 3 is greater than 2. So it's going to start with true. True 3 2. Okay, so true 3 2. So true. I think it's going to put return 3. Integer. Okay. Next. True. A, B. What? What is that going to do? That's just true, and then A, B. Function? Return function?
My device. This.
Actually, take a quick look. B is just those two. Then it's going to return is A greater than B. Yeah. I feel like this was going to happen. No. It's going to be error then.
Next. In my device. Take a picture.
I'm a genius. I didn't even have to use it. I didn't even have to check. I already knew. Exercise 4. 4 points possibly graded. Estimated time to complete 6 minutes. Below is the transcript. Okay, blah, 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 blah. Okay. If you are confused, you might find it helpful to draw out an environment diagram similar to what was presented in the lecture. I heard what you said in the lecture. We were talking about defining functions. But what is up with these arrows? What do the arrows do? I never saw does that do anything? Like, what does that even... Does it... What's the points in that? I don't understand that. Okay, whatever. Weird. Okay. A equals 10. There's a definition. A equals 3. F1. Define f x. Return x plus a. A is 3 at this point. And x is 1. 3 plus 1 is 4. Easy, easy. Okay, x is 12. Define, there's your function. Return that. Gx is 12. Enter 12. 12 equals 12 plus 1 is 13. There's a function. Then return hx. Return h6. X equals 13. Well, I guess that was completely pointless then, because now we're returning h6. So, yeah, we're not even returning. We're not returning. No. So the g function is to return h? Maybe? No, because it has no return. It doesn't have a return, it can't recall, right? No, this is the return function of g. This is the return function of h. So we go return h6. So y is 6. Return x plus 6. But x has no value within this function. So I believe it's going to be error. No. Oh man, you can't do x plus 6. The x function isn't going to carry inside. So, is the return function in the wrong? No, because your return's here. So that's fine. Will it return?
Let's see.
Return x plus 6. You got x plus 6. I mean, that's error. X plus 6. Unless that's not what it is. Well, the only way is to... I'm just going to have to check it. I'm checking myself and see what it does. Okay, I'm going to get rid of these things. I don't know why it's got these things on here. 19. It returns 19. Are you serious? Are you serious? Integer, no way. No way. Okay. Are you saying 12, 13? If 13's in here, that's 9. It can return, but I thought X couldn't be defined within the scope of H. Because you have to define it within that scope.
Careers.
Unless maybe it's because, I don't know. I guess. That was interesting. Okay. Keyword arguments.
Now that we've introduced the idea of a definition, a function in particular, as a way of doing encapsulation of information, we can start exploring some of the variations to them. And I want to show you one place in Python that's actually can be very handy. And that is that I can have a function definition that I can change in terms of how I want to think about invoking it. So let's start with a simple function here. This is a very simple function that says if the last argument is true, then I'm going to print the last name, comma, first name. Otherwise, I'm going to print the first name, comma, followed by the last name. And I'm going to expect those to be strings. And I've got a simple little implementation of over here. I'm going to realize, given some value for reverse, I'm going to show you one place in Python that's actually can be very handy. And that is
print first name, last name, reverse. If reverse, print last name, that thing, plus first name. Else, print first name,
that I can have a function definition that I can change in terms of how I want to think about invoking it. So let's start with a simple function here. This is a very simple function that says if the last argument is true, then I'm going to print the last name, comma, first name. Otherwise, I'm going to print the first name, comma, followed by the last name. And I'm going to expect those to be strings. And I've got a simple little implementation of over here. I'm going to import it into my Python shell so I can use it. But at this stage, you can hopefully look at this function and realize, given some value for reverse, I'm going to test that. If it's true, I'm going to do this, which is just a print. It's not going to return anything. If it's false, I'm going to do that. Okay? Now, here's one of the nice variations on it. First of all, that first call does sort of what I'd expect. And in fact, if I go to my Python and type it in, I can say if I do print name, and I'll do myself, of Eric Crimson, and I give false as the...
Yes. You need a diaper?
Yes.
Okay. To the diaper station.
No, not diaper. No diaper.
You just said diaper.
You said diaper.
I did say diaper.
To the diaper station.
No, no, no.
Why no?
I said no, 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 no.
Come here.
No.
Come here.
Okay. See.
Go, Olivia.
Okay.
Go, Olivia.
Wait.
Olivia, go.
Why?
'Cause I said so.
There's
1,
Oh,
2.
I go.
Okay, let's try. Let us try.
Ah, screw it. Let's put restroom break. That works.
I've only done this like a million times.
Brain. Brain.
Value for reverse, it prints it out in the order I expected. I could do, by the way, the same thing. I could say print name just to show you it does the right thing of Eric and Grimson. Notice the commas, by the way, to separate the parameters. And I give it true. It would help if I can type, so I'll do it one more time with Eric, Grimson, and true. Now it prints it out in the other order. But here are some of the variations. I could say explicitly, give the binding to the parameter name reverse the value false. So doing it in the same place, but I can actually specify it. I could similarly, for any of the parameters, in the invocation, literally say the parameter followed by an equal sign and the value that I want. And all three of these are going to print out exactly the same thing, and in fact, so will the last one. But notice here, I've reversed the order. So if I'm not going to use this kind of formalism, I have to give the parameter in the place it expects. But in this case, I reversed it. Even though the function expects first name, then last name, I've said I'm going to have last name have the binding Grimson, first name have the binding Eric, and reverse equal to false. That's nice if I forget the order, or if I just decide I want to call them in a different way. I can do some other things here, though. I can change the definition of my function to give a default value to one of the parameters. In this case, the syntax is there's the parameter name, and I'm saying let it have initially the binding of false. And that means that if I call the function, as I do right here, without an explicit parameter passed in or value passed in for that parameter, the default holds true. In this case, I'm going to assume that reverse is false, and therefore I'm going to do this particular print statement. On the other hand, if I want to change the value of that, I need to give it an explicit value to overwrite the default value. And this is handy if I've got a parameter that normally I expect just to have a particular value, but on a rare occasions I might want to change it. My invocations don't have to always pass in those values. So a nice little variation on how we pass values in to parameters of definitions of functions.
Hey, what's up, man? Still working on this stuff. Surprise, surprise.
We've now begun to look at functions. We're going to do more of those in a second. But it's important to take a little break here to talk about one other piece of
I
a
still
function.
got the thing on there.
And that was the
Oops.
idea of a specification.
How long
This
that's
is
gonna
something
last.
we're going to use to be able to decide how we want to use a function. And think of a specification, therefore, as a contract. We don't enforce it necessarily, but it's a contract between the implementer of the function and the people who are going to use it. That specification ideally will say, here are the assumptions. Here's what the implementer of this function assumed was going to be true, especially about the values of parameters. If you like, it's the conditions that a client needs to guarantee are true before they use it. And then if those assumptions are in fact met, the second part of the specification are the guarantees. It says, here's what the function will do, provided it's been called in a manner consistent with the assumptions. The way we do it in Python is to use this idea of a docstring. And there's my earlier definition of is-even. It has a condition on the input. It says, if you give me an integer, which I'm calling I, in particular a positive integer, then here's what I guarantee. That it will return true if I is even, otherwise it's going to return false. Now, you're not required to put in a docstring or a spec, but good programmers always do. In part because somebody else might use this and you want to tell them how you expect it to be used. Or because a year from now, 2 years from now, you may come back to this function and you'd like to know, what was I thinking when I built it? So I encourage you to build your own docstrings, even though it takes a little more time, because it helps you understand what's expected of a piece of code and where can I use it.
I was wondering why I did that. I mean, I guess I understand why it puts the doc string, because it kind of explains things, but I mean, you could also put the hashtag symbol thing and then put a comment in there too, so I don't know. The same difference, but enter the expression below to use this. Is up your checks. If you're confused, you may follow. Okay, def is foo. Foo's 3.
This shouldn't be so fucking hard.
What happened?
Stupidness. It only takes certain files and it won't take PDF, which is fucking stupid.
Then it won't take PDF.
So I have to turn the
That's
picture into a JPEG.
Oh, yeah. Sometimes I don't
I
take
don't know how
JPEGs.
to do that.
You can do it on the computer.
Yeah, but I tried to do the fucking thing here and it won't let me.
Sometimes, well, you can download a converter. Sometimes usually for your phone, you have to download like a app, the converter to do it. 3. I think it goes on the first line. I hope. I don't remember. I gotta double check on that one. Okay, hold on. Let's do something simple. Yeah.
See, and
Missing one requirement position argument. Why? Oh, wait. So, oh, but if it has a default function, I didn't even see that it has a default function. Hold up. If you give it a default function, then it just... Yep. Boom, 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 boom. Okay. I didn't see this part. 3, then y equals 5. No, return, god dang it. Return y times 2. So 5, 10. And here, return 10, 11. But if x is, because this is supposed to be x, right? And x is
So
defined as
PDF
this.
isn't a JPEG?
No. PDF and JPEG are two different types of file formats.
Combine files, create from photo.
Should be 11. X, 3, 0. So 3 and 0. That's 0. This one's 1. I think. 2. 2. I return 3 and x is 2. So 3 and 2. 3 plus 2 should be 5. 5. 5. Wait. No. 3. Return by 3. That's 3 and 5. There's 5 is 8. I believe. No, I got that one wrong. I got all these right except for this one. So this one's what? Probably 3. Because that's, yeah, the 5. The x doesn't carry within here. The x will be 0. Oof. Next exercise. Complete description of S equals ABC, S dot capitalize, built-in method capitalize of string object at blah blah blah. S. Hold on. As we'll see in subsequent lectures, I think
Fucking
Python is
found
an
it.
object. What?
This.
What's the name of object? this exercise, we want you to get some experience in using methods as functions. The convention object methods is to use the dot notation so that if s is string, evaluating s dot upper will return the actual function, and evaluating s dot upper will cause the function itself to be evaluated. In this case, it returns a new string since strings are immutable with every character now in uppercase. An example of this follows. It says s dot capitalize built-in method. Capitalize a string object at blah blah blah. S dot capitalize, and then it has parentheses that will do that. Okay, hold on. I need to. I want to see this. I want to see this in action. S equals ABC.
Dada.
Yes.
Juice.
Oh, she's not fucking saying.
Dada.
You want juice?
Yes.
You got your bottle?
Yes. Juice for you. Dada. Dada.
What is it?
Juice.
Juice.
Yes.
All right, let's go get juice. Come on.
Okay.
Where's your bottle?
River Street. Watch me get this one. Even though it's been a pain in the dick the whole time.
For each of the expressions in this problem, specify its type and value. If it generates an error, select type, none type, and put the word error in the box for the value.
Will you now or in the future require sponsorship? No. Yes. 20.
Exterminate.
Address. Zip code, county.
Did we even talk about this? No? Well, from what it looks like.
Yes.
Oh, capitalize. If you put capitalize, it only capitalized the first one. If you put it upper, okay. If you put lower, does that work? Upper, lower, capital. What did I do? I spelled it wrong. Oh. Yeah, okay, cool. I got it figured out. String 1 will be supper. Yeah, it's gonna go ahead and be an error there, buddy. Is lower. That's gonna be an error. String 2. Well, string 2 equals string 2. String dot capitalize. Okay, so it's gonna capital the first word. Okay, I gotta type that whole thing. Wait, no.
Over 8 years experience in large-scale music production and entertainment.
Okay, capitalize. Swap case. Swap case? Maybe it makes it all capital. Okay, index E, integer. I believe that does this. Oh, why'd I put this? Find in? No, man, I haven't tried any of these. I don't know what that does. Find in. What is, I've never seen that. One. Ah, if you what? Hold on.
Experiences.
B. Alright. Oh. Two.
On and off camera.
If I if I put find B, it'll say 2 for that, but there's more than 2 B's in there. What does index and find even do? Which channel to prefer to learn Java from YouTube? Please tell me.
My skill set in social media and
Which channel? Well, I'm learning Python right now, but I'm using this website. But I think I'm learning Python, but I think they also teach JavaScript. I haven't started messing with JavaScript yet. I barely downloaded that and I was starting to mess with it, but I haven't started messing with it yet. As far as YouTube goes, like, I don't know any specific YouTubers that's doing JavaScript right now. But this is the website. But what I think, boot.dev. That'll teach you. That one can teach you JavaScript, and then the one that I'm currently using is edx.org. So, well, I guess it's actually, I think that one will work, but I think you gotta put edx. And that'll give you the website that I'm using, which I'm pretty sure that they have these. I'm just using this website. That's the website that I'm using. And I'm learning Python right now, but these ones are, he never went over this in the video. That's what's tripping me out. Index and even swap case. I don't even know what. I don't know what none of these functions do. Okay, swap case does what I thought it'd do. Index, I don't understand what index does because there's more than just one B in there, so that doesn't make any sense. I don't know what index does. Find it in string 2. There's one in, so I guess it'd be an integer. And then index is not what I thought it was. Those are integers. That's gonna be a 1. Integer. I don't know. No, it's 1. Index exclamation. Wait, that's only the first one. Yeah, that's not the second one. I think find. Be sure to make note of the difference between the find and index string methods. I don't know what the difference are. That's the problem. Let's see. They didn't even talk about this stuff. -1.
As a tattoo artist.
Okay. Okay, so if you put index, put find, then it's -1. This is weird. Huh. But if I put like a number that's in there, it doesn't even count all the numbers. Find and index are essentially the same. The only difference is what they return if they can't find the value. Well, see, this is something that I was confusing me about find is like I used this random string, but it's got like 5 B's in there. And if I do like find B,
Past work experience as a tattoo.
it only returns 2, so I don't really understand that. So I mean, does find doesn't actually count how many you have? Like, I don't really understand. And he didn't talk about these, so I really don't understand. He was talking about defining functions, but he didn't even talk about none of this stuff. Find and index are essentially the same. This is what they return if they can't find the value. Yeah, so index will return an error, and find will return a -1, which is weird. For functions of types, you can look at Python. It finds the first instance. Finds the first instance.
I want to LOL it so bad.
Oh, like because B is number 2 in line. So like if I did S equals blah, 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 and then B at the end. Oh, well, it doesn't work. B at the end.
My password is kind of a tattoo artist, and I'm easily able to socialize and connect with my clients. Other things to talk about.
The index does the same thing. Oh, I see what it does now. That makes a lot more sense. Huh, I wish he told me that. He didn't even, like, they didn't even talk about this at all. It was just like, what? There was no video about it. There was nothing. It just went straight into this. And I was like, well, we didn't talk about this. Wait, so find in. And this one, yeah, that'd be number 0, wouldn't that, actually? Because that's the first one. And then index of E in string 1. No, that'd be 0. Right, because there was the first one, then it's should be 0. Yeah, 0. Okay, that's what I thought. Count. Does it actually count? Do I have any double letters? Doesn't look like it.
Should I put that? Okay. It says cover letter or related to specific job posting. It's like I have over 8 years experience in large scale music production and entertainment. I've had multiple experiences of being on air, on and off camera. I have familiarity with radio talk with my father, who was a disc jockey in my youth. My past work experience as a tattoo artist, I'm easily able to socialize and connect with my clients and keeping them engaged in conversation to help distract from the tattoo pain. I have been told making them laugh is probably not the best, being that I am tattooing them.
Yeah.
Brings it all together.
Yeah.
Not the best
String equals
idea.
string.
Being I am
Replace E.
But I am a funny guy.
Replace. Okay. actually. Oh wow, it replaces. Holy crap!
Wait.
And then it prints it out. Oh man, this is wild. String one was string one. Exterminate with a capital. Okay, so so. God dang it! How many E's were there in that word? 3. Okay. Replace 1, 7.
Heart.
String 2. Oh, it's number 1. God dang it. String.
Alright, our history.
Wait, find N and string 2.
Real estate.
But N is. Oh, God, this is terrible. Upper. Wait. Oh, why'd I do that? Wait. No, I thought it does. If you don't put the parentheses, then it brings up error, doesn't it? Function. Wall. That's an error, right? False? What? Is upper. Oh, it's is and upper. This is so weird. Oh my god. Man, he didn't even talk about none of this stuff. Is lower.
Lighting.
Swap case. How do I get that one wrong? Number 1 though. String 2. Number 1 is a large. What the? Wait. No, that should have worked. Let's see. I don't understand. That's what I have there. Did I put some extra? No. I don't understand. I don't know why I'm saying that's wrong. String 2 index n is not. It's an integer. This is killing me. 0 is 0. What the? was that 8? Dude. Oh, is it because I'm not doing it in order? If I do these, okay, that's literally what I put here. Oh, okay, where is this? It's because this function and then this God dang it! Of course, I didn't know it was like doing all of these in order. That's why. And N because the first one's remaining. God dang it. Index E. And this is 8 because I guess it's counting this in. Yeah, because this swaps it. Only Woodland prints it out and then swaps it back. Oh my god. Yeah, I didn't realize that. I thought it was 1 at a time. I should have read better. Assume the expressions are evaluated in the order shown that is. Each part problem is evaluated directly after the previous. Yeah, I thought they were all separate. I didn't pay attention. That makes sense. Well, yeah, and I got this one wrong because that other one capitalized the front. Oh my god. Well, that's the reason I was having issues with it. I'm an idiot. I wasn't paying attention. Yeah, it said it at the top. There's so much to read up there. I kind of just skimmed through it real fast. Write a Python function, 4th power. It takes and one number and returns that value raised to the 4th power. Okay, you should use square procedure that you defined in an earlier exercise. You don't need to redefine square in the box. When you call square, the grader will use our definition. This function takes in one number and returns another. The square procedure that I used earlier. No, it's just for finding the square root. That takes in one more. I mean, I don't know exactly what they're asking. This is what I feel
You
like.
got another boogie?
But
Oh, you need this done. Put your shoes
is
back
it to
on.
the 4th power.
Shoes back on.
I did.
You got poo poo? Do you got poo poo?
What?
Yeah,
You
got
should
poo-poo.
use the square. I don't know what it's talking about. But I feel like this is not gonna work. Yeah. To the 4th power. Crap. Yeah, it's for finding the square root of something. I don't think it's trying to. I think they mean use
Well,
square x
we'll
instead
see.
of for whatever reason.
94.7.
Yeah, I'm starting to wonder if I missed a video or something. Like, they're saying you should use square procedure. You don't need to redefine square in this box. You can call square. So I guess, I don't know. Yeah, that didn't do. I don't know what they're. I don't know what they're talking about. I'm like, I feel like I missed a video or something. Like, I don't. I'm like, what the heck? Well, it says to the square to the fourth power. So I'm doing something wrong. I don't. You actually change X in your code so it returns the initial value. Oh, X equals. I like that. Oh, that's my fault. I forgot. X equals. Yeah, that was dumb. Oh my god. I was like, what am I doing wrong? Oh, I fumbled on that one. That was retarded.
I did it. That's 3 applications so far.
Oh, ow, I hurt my chin.
One's a real job, and the other ones are kind of real jobs. Either way, they all have real pay, so.
Spend time to complete 3 minutes. Write a Python function, odd, okay, that takes in one number and returns true when the number is odd and false. Otherwise, you should.
What location are you asking about?
Oh my god.
Alexa, turn up the temperature in the living room to 73 degrees.
I've set the heat to 73 degrees.
Dang it, how do you
It
do
is
that?
cold. You hear Olivia just call.
You know, I don't even think I need to put if. I think if I literally just put this, I thought that actually returns the true or false. Hold on. Return. Oh, I guess I need to give results for this. Use the percent mod operator, not if. I got it backwards somehow. Oh, I put 2%. God dang it, why'd I put 2? I was so used to seeing that earlier. There, my bad. What? Didn't it work? Or maybe it's... they always did it where it did even. I never really saw how you do it to do odd. This is kind of confusing. Okay, so maybe that makes it every other number, and then I gotta put 1. I mean, it works. I don't know if that's the correct way to do that. I also think it's better to use return as redefining X. It may be safe in Python, but I'm not sure about other languages. Yeah, that would make the code shorter too, honestly. I mean, yeah. I mean, actually, can I just, I mean, if that's, can I just take this and put it here instead of doing all that extra? Won't that work too? Yeah. Yeah, I mean, if I'm just doing one function, then there's no reason for me to do all that extra work. I'm making a longer code for no reason. Yeah, I know that's one of the things he was saying. If you can make it shorter and simpler, it's easier to read later on.
Let's go up a level just for a second. What have we built so far? Simple objects. The idea of iteration, for and while loops, is a way of doing particular kinds of computations, reusing the same piece of code over and over again. And now we've introduced the idea of functions as a way of capturing that code. That puts us in a position to introduce another really big idea in computer science, and that's the notion of recursion. I'm going to show you an example of recursion in a second, but let me give you the sense of what recursion is about. Recursion is going to be a nice way to design solutions to problems by breaking it up into pieces that I can reuse. Divide and conquer, or decrease and conquer, are words we're going to use around here. And it's in particular a programming technique where inside of the function it calls itself. So I'm going to define a function, say f. And inside the body of the function I'm actually going to call f. Now this is the kind of thing that in high school geometry class you could get into trouble, right? You don't define something in terms of itself. But in recursion, as long as we don't set up an infinite loop, we don't call it infinite numbers of times, we're fine. And so we're going to see in recursion that as long as we have one or more base cases that are really easy to solve and can be solved directly, then I can solve a problem by reducing it to a solution to a simpler version of the same problem until I get down to a simple base case. That notion of recursion is going to nicely amplify iteration. It's going to give us a much more simple way of thinking about how to break problems up into simple pieces. And so we're going to spend the next portion of this lecture just looking at different ways of using recursion. If you think about iterative algorithms to set the stage for recursion, what do we have? They're basically looping constructs. And they are captured by the idea of having a set of state variables that update each time through the loop. So I've got a while loop or a for loop. In the case of a while loop, we talked about setting up the variable outside the loop, inside the loop changing it, usually decreasing it, until I got down to a state where I'm done, and then returning a value.
Yeah, but if you redefine x inside a function, it may change the actual value outside. I mean, it's not supposed to, though, is it? I mean, if you have it inside the function, I thought it wasn't supposed to mess with anything on the outside. It only returns the value after it, but I don't really know. I mean, I obviously haven't, tested it a bunch of times, but that would make sense if that's why you don't want to do stuff like that.
That's what an iterative algorithm does. So here's a simple example to think about that. Suppose I wanted to do integer multiplication. And yeah, I know that already happens in Python, but I want to use it as an example. I could think about multiplying a by b as the same thing as adding a to itself b times. So it's really, if you like, a plus, I've got b of those. That's the same thing as a times b. Iteratively, I would solve this by saying, I want to capture the state of the computation with an iteration variable. Let's call it I. I'm going to start it off at b because I got b additions to do. And a current state of the computation. I'm going to call it result. And I'll start that off at 0. And then my iteration is to simply, at each stage, do one more addition and reduce that variable by 1, that iteration variable by 1. And down here at the bottom is a function to do that. Multiplication iterative. Takes in two parameters, a and b. It sets result when I call it to 0. And then it runs the iteration I'd expect, that little loop right here, that says as long as b is bigger than 0, I'm going to change result by adding a to it. I'm going to reduce b by 1, and I'm going to keep doing that until b gets down to 0, in which case I'm going to return the result. Cool. Nice iterative way of trying to make that happen. There's the iteration. There's how I'm changing the computation. There's where I'm changing the iteration variable. And when I'm done, I'm simply going to return the result. Okay. I'm not going to run it.
No. Yeah, see, I know that's something that they were talking about a lot with Python, is that Python's a lot more, I guess, user-friendly. It's easier to work around things. It's not as strict. I heard C++ is like the one that a lot of people prefer. A lot of the old school kind of coders prefer, especially if you start doing it for real, for real. Python's just a good, like, entrance because it's more forgiving, I guess. Yeah, I know when you go into other coding, though, it's like it changes a lot and the other ones get stricter. And now C++, like, you gotta type a lot more stuff to do everything. Python's like less things to type and easier to work around, but yeah.
I encourage you to try it yourself, but you'll see that it actually does the multiplication I'd expect. With that in mind, now let's look at a recursive solution to this problem. And here's the way about thinking about this idea of doing successive additions to compute multiplication recursively. Again, a times b is adding a to itself b times. But I could think of that as saying that's the same as adding a to itself b minus 1 times. Okay, you say, that sounds like semantics. It is, but it's an important point. Because what's this? That's just a multiplied by b minus 1. Ooh, that's cool. Because now I've taken a problem and I've reduced it to a simpler version of the same problem, plus an operation I know how to do. Okay, what's a times b minus 1? Oh, I know how to do that. That is just a plus a times b minus 2. I could do exactly the same reduction. And I could keep unwinding this computation. I need to stop somewhere. I could keep unwinding this computation until I get down to a base case, something that I know how to do. And what's the base case? When b is equal to 1, the answer is just a. And boy, that's nice, because there's a recursive implementation of multiplication. Inside the body it says, if b is equal to 1, that's my base case, just return a. Otherwise, return whatever I get by adding a to, doing the same thing but on a slightly smaller problem, multiplying a times b minus 1. And that will again call itself until we get unwound down to the level that we want to get to. There's the recursive step. And that's a standard form for a recursive function and is a really elegant way of thinking about how to solve this problem. I could do the same thing. Let's think about computing factorial. Factorial, written in mathematically as n followed by an exclamation point, is...
Yeah, you know, I was actually thinking about that when I first started messing with the Python stuff, is I was like, because that's what a lot of people were saying, is you can get a little comfortable with the way Python functions, and then it becomes harder for you, because I guess you have to retrain yourself for the other things. Yeah. Yeah. I mean, I'd like to get into coding for real, but I mean, obviously I'm barely just starting, so I got a long ways to go. But I mean, I figure if I can start figuring out Python and actually know how to use it and stuff, then I can start learning the other ones too.
It's the product of n times n minus 1 times n minus 2 all the way down to 1, where n is a positive integer. If I wanted to solve this problem, I could say, so what values, or for what values do I actually know factorial? And that's easy. If n is 1, factorial of 1 is just 1. There's my base case and the value I want to return. How would I return it? Well, just as I did with the multiplication case, n factorial is the same as multiplying n by n minus 1 factorial. So there's the recursive step. And I've just written the body of code for something that would be a definition for factorial or fact. What you're seeing here is a pattern, and this is the idea of a recursive function. Break it down into a smaller version of the same problem, plus some operations I want to do, and figure out when can I stop breaking it down into smaller versions of the same problem because I know how to compute it directly. In the case of factorial, when I get down to a factorial of 1. With that in mind, let's deal with something that may be puzzling you, which is how in the world does the computer know when to stop unwinding this? And how does the computer know which versions of the function, of the parameters to the function to use? I'm calling fact of n. How does it know which version of n to use? We've already kind of seen it, but let's walk it through. So here's my definition of fact. Fact of n is if n is equal to 1, return 1. Otherwise, return n times fact of n minus 1. Then I'm going to call it on a value of 4, and I want to print out the result of that. I'm going to do this reasonably quickly because you've seen these pieces before, but let's look at what happens. When I define fact, in that global scope, I create a binding of fact to some code. Hasn't been run yet, and now I'm ready to run it by actually calling it on print of fact 4. Okay, here we go. I've got to call fact of 4. Fact creates a new scope inside of which n is bound to 4. And relative to that, it's going to evaluate the body of the procedure. It says, is n equal to 1? No, it's equal to 4 here. So I go to the else clause, which says return n times fact of n minus 1. Aha! I got to call fact again. I know I want to return fact, or 4 times fact of 3. That's the value of n minus 1. But I got to call fact. Great. It creates a new frame.
This is a lot. This one right here. Holy crap.
Decide
I
what
need to
we
go
want to
back.
do. N is 1.
Okay, I gotta go to the restroom real quick. Okay. Alright, hold on.
Factorial of 1 is just 1. There's my base case and the value I want to return. How would I return it? Well, just as I did with the multiplication case, n factorial is the same as multiplying n by n minus 1 factorial. So there's the recursive step. And I've just written the body of code for something that would be a definition for factorial or fact. What you're seeing here is a pattern, and this is the idea of a recursive function. Break it down into a smaller version of the same problem, plus some operations I want to do, and figure out when can I stop breaking it down into smaller versions of the same problem because I know how to compute it directly. In the case of factorial, when I get down to a factorial of 1. With that in mind, let's deal with something that may be puzzling you, which is how in the world does the computer know when to stop unwinding this? And how does the computer know which versions of the function, of the parameters to the function to use? I'm calling fact of n. How does it know which version of n to use? We've already kind of seen it, but let's walk it through. So here's my definition of fact. Fact of n is if n is equal to 1, return 1. Otherwise, return n times fact of n minus 1. Then I'm going to call it on a value of 4, and I want to print out the result of that. I'm going to do this reasonably quickly because you've seen these pieces before, but let's look at what happens. When I define fact, in that global scope, I create a binding of fact to some code. Hasn't been run yet, And now I'm ready to run it by actually calling it on print of fact 4. Okay, here we go. I got to call fact of 4. Fact creates a new scope inside of which n is bound to 4. And relative to that, it's going to evaluate the body of the procedure. It says, is n equal to 1? No. It's equal to 4 here. So I go to the else clause, which says return n times fact of n minus 1. Aha! I got to call fact again. I know I want to return fact, or 4 times fact of 3. That's the value of n minus 1. But I got to call fact. Great. It creates a new frame inside of which the formal parameter, n up here, is bound to 3. And relative to that, it does exactly the same thing. So I'm now going to go faster. Is 3 equal to 1? No. So I'm going to return 3 times calling fact on n minus.
Okay, so this is just reading that thing where you're using the function within the function. So if fact, you're calling the function within the function. God, this is so this hurts my brain. So fact is 4, this is not equal to 1, and then so it's forced to do the else, which is return 4 times fact, which is this sequence, and then take away 1. Oh man. To do it as many times as this number.
Minus 1, which is 2. That calls a new frame. There's the binding for n. And still not equal to 1. I'm going to again go to the return clause or the else clause that says return 2, which is the value of n times fact of n minus 1, which is 1. And that calls one more frame. And aren't you glad I didn't do fact of 64? Almost done. In that frame, I now say, is n equal to 1? Great, it is. And so in that case, I know that's the expression I want to call, and it says, return 1. Where does that go? I'm returning 1 to the person who asked for it. And that was that call to fact. That's great, because now that expression says return 2 times 1, the value returned by that call to fact. And who asked for that? Right there. That reduces to return 3 times 2, which reduces that one to return 4 times 6, which prints out 24.
What?
And I'm done.
Hold up. What? I wasn't expecting that.
And that was that call to fact. That's great, because now...
But you just turned n into 1. When it says return 1. What? Hold on. Man, this is confusing. Dude, I don't know. This is a trip. Oh, someone's here.
Someone is at front door. Shut up, Pepper.
Wait, I think I just realized. So, return. Okay, so this sends you here, but then when you call it again in the return, I can't see it, but it's basically running this again on the side separate from the one it's already running. I think that's what it did. But I still don't realize why you would times it by 4. So that's 24. Because if n is equal to 1, then you return 1. I thought that was like the done deal. Or I guess, dang it, return. Wait, it's saying with each one of these sequences, this goes down, but this. Oh my god. What is it?
Oh, it was a guy who's doing pest control in the neighborhood.
Oh.
He said first one's 50, every month it's 120. We need the inside outside pest control.
Yeah.
Woot de woot.
Woot de woo.
I mean, it's a good price, but I don't think we'll ever gonna use him. But kept it anyways, you never know. Especially if he's a local dude doing local shit. It's always appreciated. Keep it local.
Alright, so n equals 4. So you skip this because it doesn't equal 1. And then else return 4 times fact. And
Today's
then
an
you
early
put
day
in
for
this
sativa.
input. And then re-going through it. Oh man, that hurts. Is it because I thought after everything then it gets stuck here and it just returns 1, but I guess it returns 1 to just this one, and then this stays in else. It doesn't loop back. Yeah, because I guess if you're already in else, then it's just gonna return this. So is that basically what's happening? The only problem that's going is this one? Let's see.
Hey, Daddy. I used
N is not defined.
you as a reference, kinda. And if it does help me, then awesome. To try to find a job as on-air talent for a radio show. Because you used to do scouts and stuff. I applied for 2 different ones. One of them is iHeartRadio, and the other one's Odyssey.
I really want to grasp this, but this is kind of difficult. You run through it once, and then you hit the else. But then you have to run through it again because of this. So it's going to return this problem. And then if this goes in, so it's just going to be this part, which is in takeaway 1 is going to go in here. And n has already been defined as 4. And it's going to go in here.
This way. Okay, is there any suggestions you make if I do get an interview?
That's what I need. I need like a pencil and paper so I can draw this up, because I think that's what's really making it hard for me to understand. Because within a problem, I created a problem. And then within that problem, I created a problem. So I'm creating multiple problems, but it has to come to a resolution. Because if n equals n, then you're going to return 1. So do you return 1 24 times?
In my youth. That'd be so cool. That'd be really
Or is
cool.
it because you have 4 times
So,
the results of this?
they can get me on air. That would be a whole different career.
This is 4.
Oh yeah, whatever the 9 to 5 is, I can
And
always.
it becomes this, and then oh my god, this is crazy.
Like my schedule
Now,
is super
that
busy.
expression says return 2 times 1, the value returned by that call to fact. And who asked for that? Right there. That reduces to return 3 times 2, which reduces that one to return 4 times 6, which
Right.
prints out
And
24.
I mean,
And
how
I'm
cool
done.
would that be?
That is insane. That is like, man, if you did a bigger number, that's such a freaking ridiculous loop sequence. Oh my god, dude. Because it basically like, it goes all the way down through these problems, like a staircase, basically. And then has to go right back up to return the resolution. Like, dude, that hurts my brain,
So you
dude.
can see the computer with these scoped, nested scopes, these nested frames, nicely knows exactly where to get values in order to do the computation. And therefore, the computer knows to stop at the right time. I've just said that. Simply going to put the slide up so you can see it. Each recursive call creates its own scope. Bindings of variables in a scope are not changed by the recursive call. And the flow of control passes back to the previous scope because that was the person who asked for that function call as we did it. And therefore, I'm going to be able to use exactly the same variable name. I need to because that's the formal parameter of the function, but it's always done in a different scope, and therefore it's always clear which version I'm using when I'm calling the body of the procedure.
Yeah, because once they're defined in their own scope, then that's it. They're defined in that scope. So when it returns back to them, it's still, gosh, dude, it's,
This leaves us then with this nice comparison between iteration and recursion. Both of these pieces of code do exactly the same thing in terms of what they compute. How they do it is done differently. I'll let you decide your own style. Personally, I like recursion better. I think it's more intuitive. I don't have to remember to set up a parameter variable before I start things. I don't have to worry about dealing with all those pieces. I can make them a little different. In this case, I've changed it slightly to use range rather than setting up.
dude, that is crazy. Oh my god. That's, I don't know. That's a trip.
The iteration variable.
Oh, I need to rename this recursion. Let's see. Recursion. Let's do this. I need to type this stuff out so I can try to remember it.
Pepper, shut the fuck up. No.
recursion because it's a reoccurring, I guess. That makes sense. Screw it, I don't need to do all that. I'll just use it like this. And then I'm going to create one for this. It's called iteration. Good examples to use. You probably won't need to remember this stuff. Oh. Okay, this is an iteration. Return prod. Prod equals 1 for I. And range 1 and plus 1. And it'll do the exact same thing. That's crazy.
But I personally find the right-hand side easier to look at because I can easily see where the recursive call is. From the programmer's point of view, recursion may be more efficient. From the computer's point of view, it may not be as efficient, and we'll see that. But basically the idea is each of these things does the same thing. You get to decide which one you want to use.
Oh man, that's a headache right there. Write an iterative function. Power base that calculates the exponential base by simply using successive multiplication. For example, should compute base by multiplying base times itself. That times, right, such a function below. An iteration kind. Okay. Let's see. A function should take in two values. Base can be a float or integer. So will be an integer of greater or equal to 0. It should return one numeric value. Your code must be iterative use of the. Okay. So I need to. Oh God. Right. Should compute base by multiplying base times itself. Exponential times. Okay, base times itself. Okay. So. No. God dang it. Iteration. Oh, it wants to use iteration? Not recursion. Okay, iterative function. Okay. So Oh, did I do recurse? God dang it, it's so freaking... Did I do it backwards? It has to be iterative. Iterative, not recursive. That's recursion. God dang it. Okay, this. Okay, so hold on. Okay, so let's do prod equals 1 for I. Alright, hold on. For I and rain, I didn't. Dang it.
What do you have? Oh, well.
I gotta write an iterative function.
So I'm gonna get Cora and then I'm gonna go pick up Sativa immediately.
Like the last time.
Mm-hmm.
Mommy. 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 I'm doing.
I am getting my escrow license.
What? Oh, it's crazy.
I know, right? Huh?
My home is free.
What are you doing?
Me?
Afterwards, I might have to go with Amberly and go do a notary thing for her.
Have to do a what?
Notary thing for her.
Yeah.
Bro.
This is so hard. Oh my god.
Okay. I have one do you try wiggle us make wiggle it's too big. Let's try it. Do make wiggle. I'm not trying.
That's what I was thinking earlier, but I don't. Let's see.
This? No. Mean this? No. No! My key! My key! There. Yay! Do. Hi! Yeah! The second time I died. No, kill. What? My Yoda died. My Yoda. I go. Crack. No, not die. No, die. No, play die. Hey, come make it. Ah! Hey! Look. Neck and teeth. Why my dog? Because my teeth.
Result equals 1. Well, expand 0 result.
What are you doing, Olivia? What do you have? Get that off your neck. You don't put cords on your neck.
No. Dang it. Stop. Olivia. Where'd you get that? Stop. No. No. Stop. God, you got nails. Jesus. No, you can't do that. Oh my goodness. Okay, loop. Number of times. Wow. XP is 3 given 0. I'm going to multiply the result by the base.
Olivia,
Inspiration.
stop.
Decrease the exponent counter.
Michael,
What?
it's mean. Michael's high. Mommy. Uncle's high.
No, it's cold outside.
Man, this stuff is kinda, sorta. I mean, It's still really complicating, honestly. Well, this one was iteration, though. So I didn't do iterative function, but... No, recursion's the one where it's like it loops within itself and then returns back all the way back from itself. And then iteration is what, one sequence. Yeah. Yeah. I mean, I understand the idea of it. It's still like really a lot to log down and write a function. Compute an exponential by iteratively executing successful multiple. Use the same idea, but in recursion function. Okay. It said I did the wrong one the first time. So, I think the way... So I'm going to do the same thing, right? Which could use base by recursively calling itself to solve a smaller version of the same problem. And then multiply the result by base to solve the initial problem. Okay. So it's like... Okay, so... If...
What can you? My water. Red. My 2, 3. 2, 1, 3. 2, 1, 3.
Okay, so if base
You want up?
2,
You want up with me?
1,
Yeah.
And come here.
return
You're so funny. Ugh. You're heavy though.
Why?
I need to take a picture.
Why does this?
That's my ID.
No.
else
No.
Yep.
return
Look. It's
Base.
he.
times
What's it?
right.
Stop.
No. I want to my car.
No, wait. You got a times base by itself, exponential times. So x take away 1. I think. No, wait.
Wait.
Did I do that right?
Do it. Wait.
I don't think I don't. Yeah.
Stop.
Okay, base. Integer that's gonna be greater than 0.
Thank you. Take it. Take it.
Stop.
Take it. Take it.
I think.
Go.
Okay, so it's gonna be greater than
I love you.
1.
Thank you.
Stop. Thank you. Jesus.
Take
Base
it. Take it.
times. No, I did it wrong. Wait, no. Is
TSA pre-check enrollment. What?
return. Okay. You want to multiply base by base exponential times. So if exponential is greater or equal to 0,
No water with
turn
T.
one right.
B.
Return base maybe? No.
No, not outward.
Return base times.
What?
So maybe that.
What? And nice. Mine. And what?
I mean, that takes away 1 every time. And that's going to times. Alright, returning base, so it times itself. Once this hits 0, as many times.
What? Oh my God! Wait, Mama, get down.
Hey, what's up? I'm not playing video games at the moment, but
Oh,
what?
I get down.
It takes 2 parameters. Look more closely. Return else.
Dada, Dada,
Oh,
I'll get down.
oh
Dada,
wait.
Stop.
Dada,
You want to get down?
yes.
Come here.
Takes 2 parameters. Oh yeah, it does.
No, get down.
Oh crap.
Welcome. Jesus.
I mean, should I just put base there? No? Oh man, I did it wrong.
Whoa. What? Dizzy? Oh.
What? What? You want a kiss?
Yes.
I don't even understand what you did. Oh my god, come here. There, that better? What? No, I'm not pulling that out. Any number to the power of 0 is 1. What? What is it?
So tomorrow I have an appointment.
Appointment?
At 1 o'clock.
Oh.
To get my background ran so I can get my escrow license.
Okay.
No tests or anything needed. And that would make me an escrow officer.
No, really?
Oh.
Yep.
Yeah.
Why don't you do that?
No.
I didn't know it was that fucking easy.
Oh.
It pays good.
So, I mean, whatever
No,
pays is
don't cook with it, Michael.
all we're trying to do, bro.
Okay. No.
Honestly.
This? Yeah. Oh.
I gotta get my passport, but I don't need my ID.
We're learning Python, but I'm super distracted right now.
Oh.
Trying to.
Yeah, we got a lot going on,
I
especially
applied
with the baby.
at
I gotta pee real quick.
4 locations of different things. I'm gonna be an on-air talent or an escrow officer till I finish my real estate. So there's that. Well, I was gonna do applications all day today, and then since it's Friday, I was thinking about going up to the tattoo studio, chilling up there, and while I just sit around and wait, standby for standby, I need to make a schedule for the tattoo studio. For February. I got 3 confirmations that my applications have been approved and are now on standby for standby.
On standby. I like being on standby for standby.
It's not denied, so there's that.
Comments done by 3, but watching is 2. Oh, that's because that was my comment. That's me in the yellow. Crap, dude. I'm kind of... Number to the power of 0 is 1. So, is this what's messing me up? I'm in America. I'm from the South.
Dirty tail.
Well, but everybody on here has been from somewhere completely different, so it's a trip. It's a trip. Some people are from Canada, Russia. It's cool. People that pop in from all over. And, with coding, nope. I've never. I just started trying to do this coding stuff. Like a week or 2 ago. And this is like, some of it's like really simple and really easy. This right here is like, oh my god, this is crazy. Okay, if it's 1, then you return base. I mean, would this work? Because I can't even tell. I don't know, I'm gonna try. This loop stuff is so... Oh, man, this is hard. Okay, I did something wrong. What am I doing wrong? Okay, let's return 1. I mean, this is the way it's set up. No, it's not set up. No, wait. Wait, if you're multiplying by... its base, your condition was correct. Oh, I haven't tried C++. I'm just doing Python so far. Its base condition was correct. The one that I had, it didn't work. I'm trying to, because it's gotta, that's what I was thinking, you gotta put base here. Because whenever this hits 1, then that should turn, it should return the call to that as many times as this needs to subtract by 1. That should be right? Like, zoom in dark mode, please. I don't know if I can zoom. I don't know how to. Well, I can zoom in on here. I can make this bigger at least. I don't know how to make this dark mode though. can do this. But it won't let me change. I already have it on dark mode, but it won't change the website dark. But I could put like a filter on it or something. Could do something like that. Is that still visible? Well, this one didn't. It says line 12. What? Well, no, look, it worked for these two. Hold on. I don't understand. How does it work for some of them, not all of them? Wait. Yeah, okay, this is... It's working for these, but then it didn't work for this one? Oh, because the 0? Oh, because it can't reach... Okay, that's the only one that's wrong, is the 0, because it puts... The correct output's 1.0, and I put it in like an infinite.
Oh shit. You might have to go get the kids.
Why?
Because Amber needs me now.
Oh.
She said like now. She's headed that way right now.
No. Which Amber?
Amber Lee.
Oh. Well, I can pick up the kids. Just leave me the big car.
Yep.
Quit taking the big car everywhere. I know you like having a 6.2, but good God, what? He's burning gas.
Let me go ahead and see. I'm gonna call her.
I'm taking the family vehicle all the time. Yeah, if you call 0, then I guess I didn't make it. I didn't give it an exception for 0. But I mean,
Hey, you said you're headed there right now?
Yeah, I actually found a notary out there that's gonna be able to go there. I'm sorry,
Okay.
it's like
You're-
really crazy. My mom's at risk of having a stroke, and so like I have to get it done as soon as possible.
Okay,
Because
that's...
if she has a stroke, I can't get it done, you know?
Yeah, no, I pick up what you're putting down.
And she's got like lawsuits coming after her for like this house she bought, and she's got her husband who died a few months ago. His daughter is like trying to take her to probate court, and so like she can't. Already she was not like doing well. Like I've been trying to help her, but I feel
Damn.
so much, and like now she's got this going on.
I mean, I could put that, but I just, man, that's not, that's so cheating. But that's not what they want me to do. I'm not really sure what they want me to do. Double star?
Yeah.
I think what would happen? Double star is missing. Oh, for this? But then that would change the equation, wouldn't it? To put it to, but I get, if I did the square root of that. Yeah, that's what I mean, if I do the square root, then that's like too much. But like, And then this couldn't work, right?
Okay, never mind.
If it's greater or equal to 0.
Oh, poor Amber. That girl just never, like, man.
No. That's not what I'm trying to do.
That woman goes through way too much.
X will be an integer greater or equal to 0. Should return one numerical value. Wait, this function should take in two values.
So I don't have to grab all my stuff and go. I'll still be able to grab the kids. Oh my god.
Base can be a floater integer. XP will be an integer greater or equal to 0. It should return one numerical value. So, what is that saying? So return one numerical value. Your code must be recursive use of the... I can't even use the operator or looping constructs. Not allowed. I don't think that's gonna work, right? That's not... I don't know. Yeah, I just completely messed it up. Okay. This works for everything but 0, and I don't understand why. I mean, I understand it, but I don't know how I'm supposed to make it work for 0. Because honestly, if you multiply something by itself 0 times, because it's only messing up on that first, on anything with 0. But if you multiply something by itself 0 times, that would be 0. It wouldn't be 1.000. So how am I supposed to make it? Like, the thing does the job. But the 0, like, I mean, if I really wanted to, I could put L if, if it equals 0, then put 1.0000. Because it's doing the thing right. Think again of the power of 0. It's always greater or equal to 0. Any number to the power of 0 to the power of 0. Oh yeah, because it's still the number, it's just not multiplied by itself. Well, no, I thought it was like to the power of 1. Then what? Any number to the power of 0 is 1 by definition. I don't understand that. I thought of something to the power of 0. If there was something to the power of 0, wouldn't it be 0? Because it's, I don't. I mean, I don't know how else I would reword this. I wonder if it'll even take it if I put that, like what it'll do. I'm just gonna see. Oh, error.
Will the protest be happening at the school when you get
Oh, I can't do Elif. I guess I can't.
Question mark.
Oh, did I do it wrong?
I'm picking up your sister and then coming straight to pick you up.
Any number to the power of 0 is 1 by definition number. Huh? Oh, this is, here. I'll type it for you. That's what I'm using. After the condition. Oops. Oh my god, it said that's correct. So you know that's not what they're looking for, though. Like, this is definitely not what they're looking for. I kind of cheated the system with that. I'm positive that that's not what they wanted me to do. I still did it wrong. Like, I kind of did. I did the formula right, but I don't know how else I'm supposed to be doing that 0 if I'm being honest. If it equals 0, then yeah, I'm kind of, man. If you're getting there, it works, but you can make it shorter. Yeah, here. I'll just see what they were supposed to put. Okay, this is what they want. Where is it? If it is, see, that's what I was thinking. It was like putting the 0, then return 1, then return bits. So I thought I put that one. Didn't I put that? I thought I literally tried this and it didn't work. Did I never do that one? I thought I did that one. Yeah, but I thought earlier I tried one.
Wow.
Because it said up here, the way it describes it right here, it kind of tells you that. That's why I was trying that earlier. And it says that it'll be an integer greater than or equal to 0, so that's why I put that. And then it should return 1 numerical value, and that's why I put 1 here. Unless I had something else off. I don't remember. I could have swore I tried it like that. I thought I did. What is it?
HPS oil and gas properties are hiring a landman.
Well, yeah.
Remotely.
Yeah. It's a hard job to fill.
Remotely?
Oh, remotely? Well, I mean, technically you could...
Closing and titles.
Yeah, I guess so. I mean, I don't know.
Sit at your computer and... You know how to close for an oil company, don't you?
No.
It's not that hard.
I know how to drill, 20,000 feet, but I don't know how to close a well.
When I get my escrow license, I'm gonna apply.
I don't know how to sell a well or something.
I'm gonna apply when I get my escrow license. I'm so excited!
I put the website up here. Yeah, it is free, but if you want a certificate and you want to take the final exam, then you have to pay.
The lead?
But if you just want to learn and you're just doing it to learn, then you can do it. But it's on MIT, and it's just I'm in here. Can you see the top?
EDX.
Yeah.
.org.
Yeah, it's right here. Oh, did my filter make that too hard to see? Yeah, I think it did. I turned the filter down so it wasn't so bright, but let's see.
What is that?
Yeah. And there's also that boot.devs one too. Yeah, that's what I was wondering, because I could have swore, I thought that's what I was trying to do the first time, and then I was, thinking about it, and I was like, you know what? I was like, if I do it like this should work. But then, yeah, I wasn't thinking of the 0. That is pretty funny that I just... I was like, you know what? So 0 is the other problem. I'll just do this right here. Screw it. Oh, yeah, I could have swore I don't know. I think I did something wrong. I think I was doing this wrong. I think I was, instead of putting less than or equal to, I was putting greater or equal to. Or something like that. I think I was doing something backwards. I can't remember what it was. I got an ultra wide screen, so that's why my setup kind of looks like this, honestly.
Lafayette, Louisiana.
Well, but, or I guess I could zoom this back in. I don't know if this is better, because it makes y'all able to see better. Here, I might put it up here or something. There, so at least it's visible. Gotta use a magnifying glass. I don't think it's too bright. I think that looks better. Alright, but yeah, no, this website's free though. And then the only one I'm doing is its introduction to computer science and programming using Python. But they have a bunch of other stuff on there too. You should be able to zoom in with Control++. Oh, really? I've never tried that.
What's an ES3?
Oh my god. That's amazing. I didn't know that. That's why I was saying that. I've never tried that before. I didn't know that was a thing. What is what?
An ES3, do you know?
An ES3? No, I don't know. I have no idea. Never heard of that. What do you see that on?
I'm looking up Landman
Oh
stuff.
my god. Right, dude. With the whole Landman show, there might be a whole wave of like wannabe Landman now.
Well, most of them are remote. You don't even have to drive around like that.
Yeah.
And with me getting the real estate and the escrow, like, and then my husband used to be a driller.
Mm. Right. Let's see.
What? You broke the pencil lead again? It's okay, I got you. Oh, you might be out, kiddo. Yep, you're all gone.
What happened?
No more pencil lead.
What, she click it all out of there?
No, she doesn't know
Or
how
she
to
was
click
just
it.
drawing?
She just keep breaking it. No, that's it.
Oh, she
Used
broke
it
it?
all up.
Oh. She was drawing like crazy over there.
Mm-hmm.
I told you before. Yeah, well, I saw that you were putting C++, but I got it confused because there's another programming language besides Python called C++. So I thought that's what you were saying, was you were asking if it was C++ or something like that. So then I got it confused. So I got what you were saying mixed up with this stuff, because if you're not using Python, I mean, C++ is another one. So yeah, that's what I thought you were talking about, like the coding language.
8, 9, 8, T, 47.
We just saw an example where we
What?
AAPL member?
What?
AAPL?
Well, I'm gonna go ahead and let you know now. I'm probably not gonna know anything that you're looking up that has to do with Landman.
Well, this one they just needed somebody who's experienced in the oil industry. Because all you're doing is accepting over 9 sales.
Oh.
It's pretty much a salesman for the oil industry, but they want oil man knowledge. Not an oil man, you are.
Yeah, but I've never bought and sold oil filled things before. What? Oh, this got super dark now. Juice?
Yes.
Oh my goodness, child. Y'all are distracting me from my studying.
American Association of
Done.
Physicians.
Where's your cup? You got like 2 cups of juice right here. Drink that.
No,
Well, I thought you had to leave.
No, she couldn't get a hold of me fast enough, so she called some people up there, and there's already somebody up there, so she's just gonna meet up with them.
No. Dang. Well, she was in a hurry.
Yeah, she already on the way. She was like, I would have been down the road trip with you. She's like, I just couldn't wait. She was like, when I found out that she's on possibility for a stroke, I just headed out.
For a stroke?
Yes.
Oh,
If she gets a stroke, then she can't get the paperwork signed.
dang.
Because then her mental is at question. Her mental stability is at question.
Sounds like a lot. Alright, how do we know that our recursive code will work? Because you squeeze your brain until you squish out all the knowledge. And then you get really tired.
Honestly.
Dude, this is crazy, man. This is like, oh my god. It's like, it looks kind of simple for a second, but it's like, you're thinking like how long this string of stuff goes. Like, you're talking about like a reoccurring loops that are able to, like, it's, like, you know how you could, like, multiply a number?
Yeah.
Well, this is finding ways to, like, multiply a number, but instead of simply multiplying the number, you find a different way to tell it that, like, it equals itself. You tell it you tell it that you want it to add itself to itself until it runs out of times to add itself to itself. You know what I mean? So, like, it runs in a loop where it's like, alright, I'm going to add myself to myself until, like, I'm going to add myself to myself 10 times. And then it's like, alright, I add myself to myself. Okay, that's 1 time. Alright, I'm going to add myself to myself again. Okay, now that's 9 times. Alright, I'm going to add myself to myself. You know what I mean? And then it, like, these are the loops you're creating but you have to think that far ahead. Like, where is it going to end up? Is it going to hit an error? Is it going to get confused? Is it going to, do you make a way for it to get out of that situation, you know?
Wow.
That's like, yeah, it's really like, man.
Brain breaking. It sounds like a lot.
Oh, wow. Well, dude said that's why we have 3 different math courses on the first year software engineering degree. Well, I bet. See, the most math that I did was like, I mean, obviously, you know, high school, but when I was in the oil field, I mean, I had to calculate like volume displacement for like wells and stuff to make sure I wasn't getting a gas kick. But I mean, it was like all of the math that we were using, it was all just like pressure and volume. And it was like, we just used a bunch of different formulas and constants for calculating displacement for barrels and calculating how much pressure within a certain volume and what volume that can turn into when it doesn't have pressure, like, or how much pressure does a volume create within a certain length, kind of stuff. But this is a well-controlled class. Yeah, because here you're basically creating formulas, but like, you're not just creating a simple formula, you're creating a loop of a formula. It's like, oh my god. Oh, wow.
Walk through carefully the execution or the invocation of a function call, a factorial, in order to see how the different scope frames were created and help us sort of decide that in fact it will stop when it reaches a base case and return a value. But when I start trying to design code, I have to think about the same thing. How do I set it up so that I know it's actually going to stop? How do we know our recursive code is going to work? In the case of an iteration, we know that by making sure that we've got a loop invariant that changes as we go through it in order to make sure that we actually get down to a place where we hit the end test. So mult_iter terminates because b is initially positive, and it decreases by 1 each time through. I've set that up by making sure I change it by 1. And so I know eventually it's got to get down to a place where it's less than 1, which is going to trigger that end clause. And I can use that to deduce that I've written code that is in fact going to terminate if I give it an appropriate set of values. What about the recursive version? Sorry, as I said, mult is called with b1, and that it has no recursive call, and it stops. But how do I know that it stops in general? Well, if I call mult where b is greater than 1, it makes a recursive call with a smaller version of b. And so again, I know that eventually it must reach a call where b is equal to 1. This tells me that when I write a recursive version of a function, I need to make sure that I'm changing the parameter, in this case this value, so that I'm going to get down to that test case. That's nice, but there's another way in which in fact I could reason about my code to decide, is it going to in fact terminate, or is it going to get into an infinite loop because it's going to recursively call itself over and over again. And to do that, we can use, as a little sidebar, a nice little mathematical tool called mathematical induction. Here's the idea behind induction. If I want to prove a statement that is indexed on integers, that is, it's a statement that is applied to a set of integers, if I want to prove that statement is true for all values of some parameter n, I just need to prove that it's true when n has its smallest value. For example, n is equal to 0 or 1. And then I need to prove that if it is true on an arbitrary value of n, I can also then show that it must be true for n plus 1. And with that, I can then essentially deduce mathematically that it's true for all values of n. Let me show you a little mathematical example of this. The sum of the integers for 0 up to n, I claim is n times n plus 1 divided by 2. If n is 1, it says 1 times 2 over 2 is 1. If it's 2, 1 plus 2 is 3, and 2 times 3 divided by 2 is 3. You get the idea. How would I prove this is actually a true statement? Well, the proof says, take the simplest case. If n is equal to 0, what do I have? Then the left-hand side is just 0, and the right-hand side is 0 times 1 divided by 2, which is just 0, so it's true. To prove it in general, I simply assume it's true for some values, let's call it k. And then I need to show that it's true for k plus 1. So I need to show that this statement is true. Oh, but that's nice, because the left-hand side, I know that it's true for that. I just assumed that. I know that in that case, that is k times k plus 1 divided by 2. So the left-hand side is simply that, by that assumption. And if I do just a little bit of algebra, I can show that that is in fact the same as this. And I'm done. Having proved it, assuming k therefore it's true for k plus 1, I can now say it's true for all values of n. So this formula is always true. What does that have to do with code? Well, I can do the same thing. Here, with my case of a recursive call to mult, I need to do the following. I need to show the base case is true. Will this return the right answer when b is equal to 1? Yep. Now, what about in the recursive case? I'm going to assume that my code does the right thing for smaller versions of the problem, meaning that I'm going to assume that mult returns the right answer. And in that case, I can then say on this piece of code, if it does the right thing, then this return does the right thing, because it's simply an addition. So in that case, I know it returns the right answer for a problem of size b. And by mathematical induction, my code will always do the right thing for appropriate values of a and b. Thus, induction tells me I've got code that works.
You sent me an attachment?
I don't think so.
Oh, someone's trying to get a hold of Noda again, too. I got 2 messages for Noda. It's Emma with siding and paint. And then It's central portfolio control. A debt collector. I don't know. I've had this phone for like 15 years now. And even after 15 years, I still have people trying to get a hold of this Nelda lady that I do not know.
I do know that some people get my phone number backwards sometimes.
Yeah.
And so they've been calling the same person. Apparently they've had the same number for the longest time. Getting my number confused with their number. And so I accidentally called my phone number backwards. And I was like, oh, you have my phone? And they were like, no, I don't. And I was like, yeah, you do. And they were like, did you enter it in this way? And I looked down. I was like, oh, I did. And they were like, yeah, so you're the person that everyone's been calling for. So I was just like, what? So apparently, because I've had it for so freaking long. One day, maybe you'll find out that it was just the number was backwards.
Well, so I think to find this, how did we find this? I think we just Google searched it, right? How do we find the class? Was it EDX? You look up EDX?
EDX.org.
Yeah, maybe just go straight to EDX.org.
Because it's the free classes unless you want to pay for it.
Yeah. Yeah, I think this is where we went. And then you create a login. And, I mean, it says...
has free classes for everything.
Yeah, because it's, what is it, Minnesota? What
Minnesota Institute of Technology.
Well, yeah, they got free classes online, apparently. It's the only state that offers that.
And it's from different colleges. And so you could get a certificate if you pay for it.
Yeah, and I think there's like, yeah, you go to search, and you can literally search. Isn't that how I did it?
If it's available, yeah. But you're on a time crunch. You can't just like kind of come into the class here and there. It's literally a class.
Yeah, it is little. Yeah, because I have to keep up with it.
Yeah, I found out about that back during the COVID lockdown.
Yeah, but you can even get like a bachelor's and master's degree on here.
You get paid
Yeah.
if you want your diploma, you can pay for it.
Yeah, you can take a master's class for free, but you can't take, if you don't pay for it, then
you don't get your work graded.
Yeah, you don't get take the exams, and you don't get the certificate, which is, I mean, you can get all the knowledge, you just can't get the proof of it unless you pay for it. That's basically what it is. Was it? Oh yeah, look here. Oh yeah, look. What do you want to learn? It's right here on the top left. Maybe put Python, or should I probably put like? Oh, God dang it! Well, there's computer science I'm in the introduction one. There's JavaScript for beginners. IBM applied AI developer. Computer science for web programming. And, I mean, it'll start showing you stuff. And, like, the one I'm in for free, I'm in right now is free. But, I mean, I can still pay. If I get down towards the end of it, I can pay so I can take the final exam if I go all the way through with it, and I feel like I can pass the test and get a certificate. But it's just a certificate, the class that I'm taking. It's not like the bachelor's, but you can get a bachelor's on here too. But it's, I mean, a lot longer of a course. Oh, were you able to find it? I thought he said he was able to find it. Oh, okay. Yeah, no problem. Did I already do this? I think I did.
We just saw an example. We actually get down to a place where we hit the end. Now, what about in the recursive case? I'm going to assume that my code does.
See, this is recursive stuff that's crazy. If B equals 1, return A. Okay. Else, return A plus that formula. Take away B every time. So then you create a loop. And so it's A plus itself, B times. Unless B equals 1, then you just return A. Now, if B is 0, that won't work. Obviously. That don't work for me. Well, I'll work for the 0 anyway.
Does the right thing for smaller versions of the problem. Meaning that I'm going to assume that mult returns the right answer. And in that case, I can then say on this piece of code, if it does the right thing, then this return does the right thing. Because it's simply an addition, so in that case, I know it returns the right answer for a problem of size B. And by mathematical induction, my code will always do the right thing for appropriate values of A and B.
A plus A, B times.
Thus, induction tells me I've got code that works.
What the heck is this? Look.
I mean, if he's got to break it down like that, he's
Bruh.
gonna break it down like that. He's gonna learn, won't
It's
he?
like, all right, if you're not getting the hang of this, I'm gonna treat you like a baby. Here we go.
Honestly, there's only one way to do this.
Oh, dude, that was a trip.
We've seen some simple examples of recursion. Factorial, doing multiplication by doing recursive.
Oh yeah, my bad. I
These
got
are
the
nice
munchies.
places to start. But recursion is actually really a powerful tool, and I want to show you a very different way of thinking
No.
about recursion. on a
He said
problem that's
motivating
otherwise
us to
hard
eat chips.
solve if you don't think about it recursively. And this is to take a classic problem called.
I
the
know. I
Towers
wish I
of
had
Hanoi.
chips and salsa. I ran out of salsa.
The story is that somewhere in
I
a
didn't
temple
even
in
know what he
Hanoi,
said.
there
I'm
are
not paying
3 tall
attention.
spikes.
I gotta
We've
walk in.
seen some simple examples of recursion. Factorial, doing multiplication by doing recursive addition. These are nice places to start. But recursion is actually really a powerful tool, and I want to show you a very different way of thinking about recursion on a problem that's otherwise hard to solve if you don't think about it recursively. And this is to take a classic problem called the Towers of Hanoi. The story is that somewhere in a temple in Hanoi, there are 3 tall spikes, on which there are initially 64 discs of different sizes, all stacked together in decreasing order, with the largest at the bottom going all the way up to having the smallest at the top. And the goal of the priests in this temple is to move the entire stack from one spike to another one, moving one disc at a time, but with the property that they can never have a larger disc covering up a smaller disc. And there's a little animation you may be watching at the bottom here that's showing an example of that with a stack of size 3. We want to figure out, how would I write a program to tell the priests exactly how to move those discs so that they can move all 64 from one spike to the other. And I'm going to do a little demo to show that to you. So I want to demonstrate for you how to...
Well, dude, this is crazy. Look at this. Like, what?
There's a cat in my yard.
There's a cat?
Yeah, I don't want it to get in my
Well,
garden.
that's gonna get murked. Oh, God.
Try to use my garden as a damn litter box.
It's about to turn here. Oh, my God. Oh, my God. Are you gonna get him? He's still there. Oh, there he goes. Oh, jump over the fence. That was it. That was quick. She's got a little garden outside, and there was a cat that came out of nowhere, jumped the fence, and went in her garden. We live in the suburbs, so I don't know whose cat that is. I didn't see a collar on it. I've never seen that cat before either. I hope that cat doesn't come back, because our dogs will tear that thing up. Poor little guy. Hana is a famous problem. Really? I see. I've never heard of that before. That's kind of, I don't know. I don't like. I've never heard of this. Towers of Hana. Huh. I want to Google search it real quick because I've never heard of this. Always does it. What is it, a game? You know, see, I've heard of that thing where you can't...
No rain in sight until Tuesday, when there's a 35% chance during the day and 30% at night. The rest of the week stays dry.
Well, she heard you in here, not in there.
What did she say?
I don't know. Can you repeat that? No, she's gone.
I'll look it up myself then.
Have you heard of that Tower of Hano? What? I was trying. Oh, look, check it out. It's like a little game. Okay. Let's watch the video. I can't believe he's using these, dude. I swear to God. He must have grandchildren or something, right? Like,
I would assume so.
if he's coming in with those, I don't know.
Look at his face.
Or
look at his face though. He's like, I'm treating you like a child.
or he doesn't have grandchildren and he's hinting at his children that he needs grandchildren. You know what I mean?
True. Or he's all like, just because I know you won't fucking get it.
Yeah. He's like, I'm gonna dumb it down for you.
Make it a little bit easier.
Here you go, you babies.
Right. That's exactly what that is.
Alright.
All Towers of Hanoi, and especially how to use recursive thinking to do that. But to begin with, I'm simply going to show you solutions to Towers of
bro's
Hanoi.
planning
and see
for
if
him.
you could figure out how to write code to describe the set of moves that would solve it. Let's start with the easiest case. I have a stack of size 1. Moving it is easy. I just move the disk. If I have a stack of size 2, I know I've got to move the smaller disk to the spare place while I move the bottom one, and then move it over. Pretty straightforward. If I want to move a stack of size 3, it takes a little more work because I got to move the top disk. I got to be careful not to cover up a smaller disk with a larger one. But once I've cleared the bottom disk, I can move it. And again, move the top disk to the spare one.
Dang, that's so
that
much
I
work.
move the entire thing without covering up a smaller disk with a larger disk. Also pretty easy. But what about a stack of size 4? It takes a little more thinking because I have to really be careful here that I'm not accidentally covering things up. And it takes a lot more work to, in fact, expose that bottom disk, which I'm now ready to move. And now I got to get all of those back over again without covering a smaller disk with a larger one. And so that allows me basically...
Oh my God, that's so much work. Did you see that? Jesus. And now, just to make that more complicating, he's going to put it into code for him. Like, oh my God. And he's just like, just move in circles. It's simple. Just don't stack the big ones on top of the small ones.
Get to that point. Great. Easy to write code to do this, right?
Look, he's smarking over there too. Did you see
look,
that? He's
look,
like,
look.
he's like, easy, right? He's like,
Yeah.
I swear.
Cakes. Piece of cake.
He's got like a little bit of attitude to him, I think. I'm
Right.
just saying.
Probably not. But
Probably not.
if I think about it recursively, it's really easy. So what does that mean? I want to move a stack of n disks. And recursively, I would say, if I already knew how to move a smaller stack, what's my solution? Oh, that's easy. Move a slightly smaller stack to the spare disk. Now I can move the bottom disk and move that stack to the target. And what does it mean to move that stack to the target? Move a slightly smaller stack to the spare disk, move the bottom one, and move that stack. And I'll just keep unwinding that until I'm just moving single disks. Recursively, this is easy to see, and that leads to a very natural implementation. Okay, what you saw in that demo is that it's going to be hard, even if you watch things like moving a stack of 3 or a stack of 4, how would you write the code to do it? And then what you saw is if I think about it recursively, it's actually really easy. Because recursively, what do? I solve a smaller problem. Move a stack of size n-1 onto the spare disk. Then I've got just one disk left on the bottom of it. I move that one, it's a simpler problem. And then I move that stack that I temporarily moved to the other side back onto the place I'm going to. Recursively, this is really easy to see. And so even though this looked like a very hard problem, it's very easy to write code to do it. And so there is, in fact, a little set of code that says, I got a function that simply says, print an individual move from the from stack to the to stack. And then here, notice what I've got. I've got a test for a base case. If I've got just a stack of size 1, I'm just going to print the move to take it from to to. Otherwise, I actually now have to solve 2 recursive problems. So it's a little bit different. I'm going to move a smaller stack from the from to the spare spot. Having done that, I'm going to move the simple case to the place I'm trying to go to. And then I got to move that smaller size stack from the spare over to the to spot. But the code itself is really straightforward. And if in fact I go and run this on a stack of size 4, it gives me very nicely all of the moves I want to do to move that stack over. What I want you to see here are 2 things. One, stack of size 4. It
4 P1.
gives me very nicely all of the moves I want to do to move that stack over. What I want you to see here are 2 things. One, I can have multiple recursive calls inside of a function body. It's perfectly fine. And 2, this is a problem that I suggest is really hard to solve iteratively, but elegantly easy to solve recursively.
Well, yeah, because you put it in a loop. It's kind of crazy because, well, I was messing with something. Like, I was doing one problem earlier, and it was like, it felt really hard trying to think of the code for it. But then when I figured it out, I was like, all I had to do was like think of what I would do. Like, how does your brain work? Like, what are the conditions? I don't know. I'm gonna put this and save this because I feel like I'm gonna need this. Okay, let's do. I can't see. Plus the string of. Uh-oh, what'd I do? Oh. The print move. Okay, so he uses the print move. So he creates a print move function, and then he uses the print move function within the towers. Keep them separated. They probably could have done that all in one function, but I think, yeah. Then it'd look more complicating though. There's the print move function. What was that about? You okay over there?
Yeah.
Sounds so angry.
A lot.
What is?
Just trying to find a job that would work.
I'm trying to find a job that work, that pays. Yeah.
I do like the remote aspect of things, but I also like the idea of dressing up.
When was the last time we had like a normal job?
This time I had like a normal job. Does stage production count? It's kind of normal. It's like construction.
Kind of, yeah.
Building giant music
I
festivals.
mean, but that's not normal. Like where you don't go in every day.
No, it's per gig.
Yeah.
A normal 9 to 5.
Yeah. But it's something wrong. Oh,
I mean, technically, my tattoo shop was a normal 9 to 5,
yeah.
but I didn't have to dress any specific kind of way. I guess just my tattoo studio. The last time that I've had a other job
Yeah.
was a bartender. Does that count?
Bartender.
It was my last regular job. Before that, but that was just weekends. I don't know. It's been a minute. It'd be cool to have like an office job where I have to like dress up in business.
What do you call it?
Work clothes, but
Tower of Hana there. Oh, hey, Black Cat, what's up, dude? Now blindfold and do the code. Oh, God. Sorry, I just saw that message. Yeah, this does, man, it's a trip. It's a trip. Okay. Yeah, see, that's the only thing is like it gets complicating when you start writing it out in code and like looking at the code in your head. It's trying to think of every different like little thing, especially like with the code stuff. But it's like, as a person, you know, when you're sitting there in front of those items like he was, and you know what the rules are and you know what to do, I mean, you're able to do it. And that's all you're trying to tell the computers. You're trying to give the computer the rules. You just have to think about like how, like, why do you do what you do? And like make sure that the computer knows every single like situation. But you have to find a way to put, because like sometimes you can make it like string on like really crazy, but yeah, it's it's so hard to explain. I don't know how he is able to explain this stuff, honestly.
And I want you to think about that notion of break it down into a smaller version of the same problem, assume that can be solved, build your solution with that and other simple operations, and let the recursion then unwind it to get to the solution that you want.
This recursion stuff's pretty cool. Like the infinite loop thing. That stuff's pretty crazy. The greatest common. Okay. The greatest common divisor of two positive integers is the largest integer that divides each of them without remainder.
oh wow.
The largest integer that divides. What? The greatest common divisor of two positive integers is the largest integer that divides each of them without remainder. 2, 6, 3. Oh, okay, I see what it's saying now. Multiples, yeah, that would have to be 1 because there's no. Okay. Oh, yeah, I see what it's saying now. It's because 2 is the biggest number that can be divided by both of those. 6 is the biggest number that can be divided by both of those. 3 is the biggest number that can be divided by both of those. Is what anything higher than 3 won't also be able to divide by 9. The same thing with this one. 1. That's like when in doubt, 1. Oh my god, you can hear the shark song in the background. Because Olivia's listening.
Yeah.
She's got it playing in the background.
I was totally swaying to it too.
Dude, I forget. Oh, were you really?
I was like, do.
Oh my god, that's crazy. Oh, I forget how well this mic picks up like crazy. I'm like, ugh. Especially when I got on sensitive mode, it picks up everything. It was wild. I didn't even notice. Writes an iterative function that implements. Okay, iterative means that it doesn't do the loop inside of itself. So, write an iterative function, that stuff, that implements this idea. One easy way to do this is begin with a test value equal to the smaller of the two input arguments and iteratively reduce this test value by 1 until you either reach a case where the test divides both without remainder or you reach 1. Oh man. What? You want more juice?
Yes.
Are you serious?
I want some.
Dude, I just gave you juice.
Some.
Oh my god.
Well, I'm about to go get Cora as it's Tiba.
I'm about to go on your trip.
Mm-hmm.
You don't want to take this one with you? No! Oh, Jesus!
She wants some chips.
Oh my god, well, I gotta get you a bowl or something.
Yeah, not on the couch.
When 5 seconds should just knock the whole bag over.
Uh-huh.
You're crazy. You're crazy.
Alright.
Okay.
Well, I put in a couple resumes. Hopefully I hear back from the fun ones. And if not, I'll at least have my escrow license by tomorrow. Which would make me another thing to add to my portfolio of things that I do all the time and never. So cold. Which car did you take? The Escalade this morning? Oh wow. Well, it's that time. My
Uh, this looks like it's gonna be difficult, I'm not gonna lie. Like, it feels like the crazy part is it's simple when you're looking at it after you have the formula. You're like, oh, duh, this makes so much sense. But trying to come up with it on your own is like probably the hard, like, I feel like that's the hard part, is trying to figure that out yourself and put it together to where it makes sense. But when you see it and you read it, you're like, duh, like that makes so much sense. So, let's see. One easy way to do this is begin with a test value equal to the smaller of the two input arrangements. So I need to use dark reader extension. What is that? Is it like for the website or something? Yeah, I forgot to zoom in. Because I could, let me see. Chrome Web Store, Dark Reader extension. Oh, do they have it for Firefox? Because I use Firefox. I mean, I have Google Chrome too, but I usually use it on my left screen. I got like 3 screens, and I use one web browser for each screen so they don't get like mixed up. But let me see. See, because this is like, I have my dark, like this is how it usually looks, but I guess like with certain websites where they only have white, then it, I don't know. Oh, look, it's for Firefox. Let's try it out, try it out. Oh, there we go. Please pay. Today is January 30th, and we kindly ask you to complete the payment. I mean, can I try it first? Please make it. Oh. Hold on. Is it working? Oh wow, it does work. Oh my god, that's amazing. Dark, light, brightness, contrast. Ooh. Oh, that is cool. I've never heard of that before. That is super awesome. I like that. Thank you for that, dude. Seriously. Oh, let me close that. Dang, that's amazing. I didn't know, because I mean, I guess I never really tried to look anything up, but I just figured that was it. Oh, and it even, the way it highlights these? What? Does it actually color these on, what? How does it know to do that? Because this is like in the like Visual Studio Code. This is, you know, it changes the colors of the different meanings. Like, I mean, if I were to put like an integer, then it usually be green or something. Well, I guess it's just red, but oh, that is interesting. Yeah, because these are variables. Variables stay white. That's okay. That's cool. I like that. Okay, so I mean, this is a test value. So I need a test value equal to the smaller. Okay, so we'll do if input. Need to begin with a test value equal to the smaller of the two. Okay, so if A is greater than B, if A is greater than B, then C equals B. I feel like I'm probably making this more complicated than it needs to be. Else C equals A. Okay. I'll do that first. Okay. Easy way to do this is to begin with a test value equal to the smaller. One of the good ways to solve a task is to try to look at how you try to solve the task yourself for the case you already know the answer to. Yeah, that's what's crazy about it. That's what I was saying earlier is like, it's like one of the problems, like when you're thinking about it in code form, like I don't know why it feels so complicating, but whenever you're thinking like you know you could solve like a simple task and you know like what you can do and can't do, for example, how to get to number 3 from 9 and 12. Yeah, so if I was looking at 9 and 12, yeah, I guess I would look at the smaller number. So I guess this is how I'm trying to find the smaller number. You find the smaller number first. And then, I mean, all I really do is think about what it can be divided by. Hello? Okay. All right. Okay, so yeah, first find the smaller number, and then I usually see, like, I think I would see if 9 is divisible by 12, but it's not. So then I gotta find out what 9 is divisible by. Wait. Okay, so I gotta create a loop thing, right? For it. No, because this isn't a loop. This isn't This is iterative functioning. So you don't do loops, right? Like you can't use the function within the function. Let's see. If a okay, let me see. One easy way to do this is begin with the test value equal to the smaller of the two input arguments. Okay. If A is greater than B, C equals B. Otherwise, C equals A. Okay, I don't know if I did the F. I forget how to do the semicolons on this. I don't remember if it's... Let's see. I'm going to write it on here so I know if I'm messing up because there's no debugger on this. Yeah, I messed up somewhere. Let's see. Was it on this one? I always forget which one. I think the else is supposed to be here. Local variable C is this. Well, do I need to put like... I don't know. C equals integer shoot, I just put 1 there. Well, leave me alone now. Local variable C is assigned to, but never used. I think I'm doing something wrong. Hold on. Let's see. Close integer. And then no, it's not here. I thought it was like I had to do it here. What am I doing? I don't know what I'm doing wrong. There are max and min AB functions in Python. It's easier to use than ifs. Oh, there is? Oh, see, they never tell me about the good stuff. Is you use a regular loop. Recursive means you call a function within itself. Yeah. So I could use a loop, I just can't use its own function against itself. You can use like a while loop or something. There's a max and min. Okay. Let me see. Let me try that because I haven't heard of that yet. They don't tell us about the good stuff. Okay, let's do A equals 5, B equals 6, and then I'll put max. I'm gonna try these out because I've never used this before. A, B, 6. Ooh, min. Ooh, that's cool. Okay, awesome, awesome. Thank you. I didn't know there was a function for that. Okay, so min. Let's do this. C equals of A and B. Oh man, that is so much easier. Okay. Test value equal to the smaller of the two inputs arguments, and iteratively reduce this test value by 1 until you either reach a case where the test divides both A and B without remainder, or you reach 1. Okay, so I have to have it try to divide itself by the C number. Okay. I have to make it try to divide itself by the C number until it equals the other one. And every time it doesn't, it subtracts 1 from C. So how am I gonna do that? And like I guess like I have to use like a. Let me think. Do I use a 4? I gotta use some sort of loop for that. I think it's like. Let me see. And iteratively reduce. Okay. Begin at test value. If I don't even know what that says. If C if you're okay. If C divided by B equals 1. I don't know if I'm doing this right. Hold on. Let me think. Okay, so you take the lowest number and you divide it by that. If it equals 1, then result do it in a loop though? Because that if I put if, it's only gonna try it once. I gotta do for. I don't know if that's gonna work. Hold on. I need to put it in here or something. I don't even know what that is. That's a certain type of algorithm. Okay, yeah, I did something wrong. Four is not gonna work. That's what I need. If, but if isn't a, or maybe I do for if. I don't think for works like that though. Okay, CB is equal to 1, results equals C. Else. Take away 1. I need to find a way to loop it like that. Or every time this doesn't work, then C take away 1, and then you C take away 1. Okay. C take away 1 and then try again. How do I put that in here? Or maybe I'm doing it backwards, like a while. If while not, maybe. What if I do something like that? Expected an indented block after the, oh yeah. Okay. Oh wait, no, I gotta push these over because they're in a diff, right? God dang it. This is supposed to be over, right? Oh, screw it. I don't know. Okay. While C divided by, no, I'm not supposed to put B. Okay, C is the minimum number, so while C divided by the bigger number, what is the max between A and B, while it does not equal 1, C take away equals 1.
2, 1, 2.
Else results equals 1. No, else results doesn't equal 1, it equals C. What? What? You want juice?
Yes.
Again? Oh my god. Results equals C.
Dada.
What?
Oh my God.
Return C. Okay, while C divided by the max number does not equal 1, C take away equals 1. Right? And then that'll keep looping it back, right? While that. And then else return C. Tab for int. What? You need a kiss? Okay. Come here. You want a kiss?
Yes. Uncle.
What? Okay. I have a cup of juice. You want your cup? You want a bottle? Oh God, you're so picky. What'd you do with your bottle? Are you serious? It doesn't fit on this cup. What'd you do with this for? This one? Oh, you got too many cups. Here. Okay. So. Okay. G, C, D. Okay, let's try this. 9, 12. Crap. It's in an infinite loop. Did I do this wrong? Dang it. I think I did this backwards. Let's try it. Let's see. Alright, hold on. Division by 0. 2. Oh, yeah, dude, you're good, man. I appreciate the help, though. Don't forget, you're on the other side of the world. Dang. God, where y'all at? Jesus, 2:30? Oh, my God. It's 3 p.m. where I am. Y'all are literally on the other side of the world. That's crazy. Ugh. Crap, I don't know what I'm doing wrong, though. Okay, let's see if... Wait. While does not equal 1. Let's see. Oh, wait. I'm not typing this wrong. Division by 0? There shouldn't be division by 0. Because it keeps taking away 1 until it gets to 0. Why is it getting to 0? I'm doing something wrong. Because I'm using the max number 12. So it's going to use 12, right? Like, A equals 9. B equals 12. Okay. 12 divided by 9. And that doesn't equal, so then I do 12 divided by 8. 12 divided by 7. 12 divided by 6. Because that equals 2. Oh, no. I don't need to put 1. I need to put, if it, an integer. No, it can't be an integer. It needs to be able to be an even number. So if it does not equal a multiple, it's how do you make it to where does not equal 1? I need it to where if it does not equal a multiple of 1, a whole number. If it does not equal absolute. Let me try that again. Absolute takes exactly 1 argument, 0 given. An absolute number, but it needs to be like any number. How do I? Are you gonna make it live tomorrow? I mean, I'm gonna try to. I'm trying to stay on this the coding stuff as much as I can, cause I got free time right now to do it. So I'm trying to learn like crazy. Is it Friday? It is the 30th, January 30th. Is it Friday? Yeah, it's Friday. Yeah, it's already Saturday over there. Yeah. It sounds like well, I know the other dude's in Russia. You got to be in like you could be in Russia or somewhere over there. You're on the other side of the world. That's a trip. What's the formula for like a whole number? Let's see. Absolute. Oh, you know what? If it does not equal basically any number, it just needs to be a whole number. It needs to be it's gonna compute it as a float, and I need it to be a whole number. If it does not equal a whole number, that's it. If it does not equal a whole number, okay, appreciate it, man. I'm gonna be doing this stuff as much as I can anyway, so I figured I was like, I might as well stream it, because if other people are interested, then we could all try to learn together, I guess. So let me see. I'm gonna see if there's gotta be a way to. Because I know how to do the two, like I know how to find the value for a whole number. Does not. Let's do C %1. Equals. Can I make some expression here? Oh yeah, that is what I meant. Hold on. 12. False. I don't think that's gonna work either. No. Division by 0. Yeah, it's gonna keep. I gotta figure out a way to. Six divided by 6. The last non-zero remainder is the GCD. GCD is 6. Greatest common denominator of 18 and 12. Divide 18 by 12. Remainder equals 6. Divide 12 by 6. Remainder equals 0. The last non-remainder. Oh, wait. Come on. Does not equal 0. Is that what it is? Because that does the. Hold on. because I'm not writing it that same way. Remainder. Eighteen and 12. Divide 18 by 12. Divide 12 by 6. Use percent for the remainder. It's not equal. I don't know the. Like I get it, but I don't know how to type it out. I'll do this. Oh, instead of doing that, maybe before it gets to it. Now, would that work? I'm messing up. Ugh. Full screen blur here. Oh. That's because I got this all. I thought you were going to bed, so I was trying to keep you up, but. I'm doing this wrong. I don't know. But it's not. Well, if I can put this as a whole number with no decimal, that's really like what I was trying to do. I need to, but I don't want to sleep. I'm sorry, dude. Because like I figured out a way to make this work. And I mean, that's probably not the best way of doing this, but I figured out a way to make it work. But instead of a 1 here, I need like any whole number. Just it can't be a decimal number. I don't really know how to write that in coding. Oh crap, that didn't work. Because 9, isn't it? What is... Or can I just put integer? C equals... I know on this one I'm using iterative function. I think they're gonna make me do recursion on the next one, so that's why I'm not doing that. Why is that returning 9? 12, that's not a... What? Integer equals... Why is it saying that's false? Percent C. Is greater than 2% encoding. Oh, that one keeps giving me 9. I don't know why. Now it's not even running an infinite loop. It's just doing 9. Oh, because I have... Oh, well, it does not equal 0. My bad. I forgot to put that. Maybe that's what I was messing up on. Oh, there it goes. 6. Oh, it's not a multiple of 6, though. No, the closest denominator would be 3. Does not equal... It's called modulus. I don't know what that is. Does not equal... integer. Division method, because I can't make it an integer. Does not equal... I don't know how did... let's see... All I needed to do is this, put this as a whole number, and I don't know how to, if C does not equal, What is called modulus? Oh, the percentage thing is called modulus? I didn't know that. Oh, okay, that's what you're saying. It's not a... In coding, it's not a percentage sign. It's called modulus. Because I know I can find even numbers if I use 2 modulus. Right? I didn't know exactly how modulus worked, though. I mean, to determine a whole number, I thought if I just put 1 modulus, then that would... does not equal... Zero. It's showing 6 though. Why is it showing 6? Return C is 6. So it subtracts it 3 times. But then 12 divided by 6 is 2. But that's not a multiple of 9. Okay, so that's work. I don't got the code right. That's working, but I just created a multiple of 12, not a multiple of 9. God dang it. So I just realized that's all I did is I found the closest one that could be divided by that. That's why that's not working. It gives a remainder. Jeez, 18 and 12. Looking at the remainder, 18 divided by 12, remainder equals 6. I mean, I've been using 9 and 12, but when the remainder becomes 0, the last number you divide by is the GCD. I don't know how to put that in the coding, though. I mean, because I got this set up to where it finds the closest whole number for 12. But that's not going to work because it also has to be equal to... It has to be a multiple of 6. Or a multiple of A. What if I do that? That won't work, will it? No, I don't think so. I feel like there's gotta be some sort of... Because I need it to be a multiple that can also be a multiple of A. Wow. God dang it. Because now I'm just finding the nearest... Man. God. You need a remainder. Equal to... Need to store a remainder. So I need a... I mean, I got this loop, so I need to find... I mean, how am I gonna... I need to store a remainder. I mean, I need to... Okay, if that's my first result, I need to store that result somehow, and then I could use this same formula for the other number. While I need to do something like return. AU Gladian. Efficient method for computing the greatest common denominator divisor. It operates on the principles that greatest common denominator equals greatest common denominator mod b until the remainder is 0, at which point the last non-zero remaining is the greatest common denominator. Divide the larger number by the smaller number to find the remainder. Replace A with B and B with R. Okay, example 252 and 105, 252 and 105. Start with one number equals until you hit 0. The max number you put on this side. Example, greatest common denominator 252 and 105. So if you do 105 times 2 plus 42, if the max number is equal to... Why are both of those numbers changing though? The remainder is 42. Then you put 42 down here, and then... temporary number equals B. So the answer is 6. Oh, wait. 12. I don't even know how that works. 12 modular. I've never dealt with this modular thing. I know what a percentage sign is, but this modular thing's tripping me out. Like, I don't understand this. Let's see. Bigger number. Okay. I'm just like, man. Open paint and do normal division. I mean, 12 divided by 6 is 1, but, or 2, but how is what it is? Okay. I've never heard of this before. 'Cause I don't even know how the modular thing works, like, or do normal division. I mean, I can do normal division. I mean, 12 divided by 6, I mean, it's 2. But what is, I don't know what the modular, I've never heard of. Arithmetic operations. What is... Well, these are arithmetic and bitwise operations. Placeholder for numeric values uses. Two related concept modulo programs. Modulo operator. Mathematical operation module. A module is simply a I don't know. understand. What is B, the maximum number? Mod, what is left over after dividing? Modular, it's what is left over after dividing. 12, 18. Modular is the remaining number. Well, I know 18 take away 12 would be 6. But this doesn't make any sense to me. What? I don't understand this modular thing. Like, this is... I've never heard of this. Oh my god, this is killing me. It calculates the remainder of a division operation between two numbers. So if 18 divided by 12 is 1.5, why is the remainder 6? I don't understand. And given two integers divided, the modular operation can be expressed as, where R is the remainder after dividing A by B. 1, because 10 divided by 3 equals 3 with a remainder of 1. 15 for 3, because 15 divided by 4 equals what? 15 divided by 4 equals 3 with a remainder of 3. You have 17 candies and 5 friends. You give each friend 5 candies that uses 15. 15, 16, 17, so 2? I mean, 2 candies left, that's your remainder? Wait, so is it... How many is left after the last whole number you could divide it by? That... Dude, I haven't heard of remainder since I was like in elementary school. Well, like, nobody uses that anymore. We use like decimals and, you know, percentages and the fractions, but like remainder, I haven't seen the R. I haven't even heard of remainder since like elementary school. I never thought I would. What? I forgot what remainder even was. Dude, I remember when we used to do that. We used to use remainder in school before we knew what decimals and fractions were. And then we learned decimals and fractions, and then that was what? That's all. So 18, the module, I don't even know how you would actually say, because you said it's called modular. So 18, the module 12, I don't even know if that's saying it right, or if there's a proper way of saying it, because I've never heard of this module thing either. But all this thing does is finds, it divides that by that as many whole times as it can, and then it tells you what is left after it divided it as many times as it could for the whole number. 17 mod 5 is 2, because the closest you get to 17 with 5 is like 5 times what? 3 is 15. 15, 16, 17. God, I remember when we were like kids and we used to have to like do certain problems, and when like you put your answer and then you put an R for remainder and like 2 or whatever the remainder was. But God, dude, that was like in elementary school. What's 17 divided by 5? 3. I don't know what you were talking about that part. No, you're just saying because 5 times 3 is the closest you can get to 17. So you do 5 times 3 equals 15 with a remainder of 2. And you add 2 and it equals 17. Oh, you're good, dude. I've been scrambling, learning different stuff, and now I'm all like, I didn't know what this sign did. It's apparently called a modular. That is crazy. Dude, I haven't heard of that in so long. The whole remainder thing, like, the modular of 2 is 0, because 8 divided by 2 is exactly 4 with no remainder. Oh my God, this is crazy. That hurts my brain. Okay, I totally forgot what I was doing before all this. So can I copy that? I don't know. Hold on. Okay, let's try this. Okay, while B does not equal I don't know if Python uses that though. Integer temporal. Yeah, that's what I was thinking. I was like, I don't think that works for Python. Okay, if, well, let's see. While B is God dang it. Okay. B equals A. You're saying A and B wrong. No, I put the wrong thing there. But I still gotta get the bigger number, right? I mean, that won't work with just any number, right? Or I guess. So I don't even have to worry about what the. Okay. I gotta see how this works then. Yeah, that's why I put that. But I don't think it'll let me use this one in the. Here. I think in the program it won't let me use that. So I think I gotta put. God dang it. I don't know how to do this where it'll take it. There it goes. Okay. God dang it. See, I like putting this, but every time I put this, it won't, like if I put it in here, I don't know if it'll take this. It's kind of like a little butthead about it, honestly. Let's see. Well, this last time I wasn't taking that, the not true symbol. I tried to use that on one earlier and it wasn't taking it. Oh, it took it. There was one earlier, it wanted to take the not true symbol. It kept saying it was an error. Okay. If A is less than B, A equals B, B equals A. Okay, so while B is not equal to 0, C, okay, so that's automatically going to kick in. And then C is equal to B, so now C becomes B. B is equal to the module of A and B. So B is still whatever that number is. So let's say I use like, if I'm using 9 and 12. Okay, so it's basically C. Okay, so if I have 9 and 12. So it's going to start off, that's all, B is obviously not 0. And then C is going to become that. C is going to become B. And then equals, what is A? A is 9. And, okay, so now this number won't be 12 anymore because it equals this. And the remainder of 9 and 12 is, what, 3? 9, 10, 11, 12, 3. So now B becomes 3. And then A is 9 equals C. Wait, what is C? So C was 12. So then then A becomes 12. Wait. And then C becomes B. B is no longer 12. B is 3. Because B still does not equal 0. And then C becomes 3. And then it moves down. And now it's... So A's... Oh no, A's 12 now. And the constant of B is now 3. Oh, I don't know why I changed that one. So now it's 12, 3. Well, 3 times 4 is 12. So this would become 0. So B would become 0. And then A would be, what is C, 3? Yeah, C's 3 now. So A becomes 3. And then oh wait, that's right. B already became 0 here at the end of this. So then return A is 3. Oh yeah. Jesus. Great number, small number. It's all good. I wanted to figure it myself, but honestly, I would have probably would have figured out a way to do it, but I definitely wouldn't have done it like this, because I didn't even know what that modular sign is. But I mean, this doesn't, the way that they're explaining to do it wasn't like that. It's all good, man. I mean, it's a learning thing too, because I just learned stuff. All I'm trying to do is learn stuff. So, in all honesty, I didn't know what this modular thing was. So, I mean, I learned what that was. But yeah, but I mean, I could still figure out another way to do it with what they were saying. I mean, I was kind of like close to having it, but what was I doing wrong? Oh yeah, I was only finding out what one of them was. So I wasn't doing it exactly correct. Yeah, because I was only finding one number that was divisible by a whole number by the first number. But that's what it was saying. It was like you test the test value equal to the smaller of the two input arrangements and iteratively reduce this test value by 1 until you either reach a case where... Yeah. Yeah, because like if I do it the way that they want to do it... Let me see. I mean, I could still try to figure out how they wanted me to do it. Because they wanted me to do it like this weird way anyways. And what they're saying is you begin with a test value equal to the smaller of the two. Oh yeah, good night, dude. No, it's all good. Hey, you helped me learn some stuff. I didn't know what that module stuff was. So, I mean, either way, like and he was using that, and he wasn't explaining what it did. So, all right, good night, man. Let's see. Just begin with a test value equal to the smallest of the two input arrangements. So. Oh, what the heck? Okay, so equals A and B. All right. Now iteratively reduce this test by 1 until you either reach a case where the test divides by both A and B without a remainder, or you reach 1. So while A divided by B no. While A divided by C plus B divided by C actually, I would do it like this. Oh, crap. Ah, that worked. I found another way. Oh. This is how they were wanting it done. look. Check this out. Check this out. Oh. Alright, let's see. Dang. Yeah, that... Okay. Okay. Oh, you're still here. I'm surprised you haven't got to sleep. I feel bad. I think... Because, look, I would have never figured out how to do this because it's even asking without remainder. And it says... Like, if you read it, it tells you exactly how they want you to write it. But I would have never figured it out because I didn't know what this freaking thing was. I thought it was, like, I thought it was a percentage thing. But, like, this is basically how they want to write it. Because they want you to first find what the smaller one was. And then, you know, as long as there's, you know, have them divide by each other. And as long as there's a remainder, then continue... reducing it by 1. It was like reduce this test value by 1 until you either reach a case where the test divides both without a remainder or you reach 1. Yeah. Well, actually, I did one thing wrong. So, until you either reach a case where the test divides both A and B without a remainder, which I did that, but I didn't put or you reach 1. I guess that'd be another way of doing it if I didn't do it like that. No, dude, I kind of needed that information about how this thing worked because because it's like that's all I was like, how do you calculate that without getting a remainder, dude? Like, I was like, what? Like, it was killing me. But I think this dude also, like, I'm taking a class about coding, and there's a lot of things that he's kind of assuming that you know. Like, he's assuming you know what this is, and I didn't know what that was. That looks like a percentage sign to me. And when you put that, it means that this is supposed to be a percentage of this, so I'm supposed to get a factor of what that is. But that's not at all what that's used for. I'm like, dude. And I haven't even heard of a remainder since, like, freaking elementary school. That's, like, crazy that that's even, like, used. Like, I don't know. That trips me out. Yeah, no. Hey, it's cool, though. Because even when you gave me a code, I still found out a way to take what I learned that you showed me and turn it into my own code the way I was doing it earlier. So it still worked out. And I learned. So ultimately, that's what we're trying to do. What are we at now? You use it a lot, dude. The only time I've ever used that is like a percentage of something. Like, I mean, I worked in like the oil field. I was like a driller, but all we did was calculate like pressure and volume. And if there was a percent, like percent was used for like, I mean, it's percent, you know what I mean? We didn't do like math like remainders and stuff. It was all volume and pressure, like hydrostatic pressure. Like that was the main thing, is learning how to calculate hydrostatic pressure. Estimated time related. The greatest common divisor. Yeah, the greatest common divisor of two positive integers is the largest integer that divides each of them without remainder. A clever mathematic trick due to... Dude, I think this is what you were talking about, the Euclid or whatever, however you see that. I do not sleep on top, but I don't want to sleep. Oh my god. Do you got, like, sleeping problems? They have medicine for that, but I don't know. I mean, the sleeping medicine usually, like, that's really ends up being dangerous. A clever mathematic trick, dude. It's easy to find greatest common divisors. Suppose that A and B are two positive energies two positive integers. If b equals 0, then the answer is. Otherwise, greatest common denominator AB is the same as greatest common denominator B, a modular B. Dude, look, they're talking about what you were just telling me. Oh my gosh, that's crazy. Curious one. I mean, what do? You do like math and stuff? I guess if I find anything curious, I do not feel asleep. Have you ever done coding? I mean, I don't even know what you got going on. Cause like, man, I've never. It's hard to relate this to what I did because it was all just like all the math that we did. Like, I don't know, like if there's a. I'm basically looking at like a mud kill sheet. Yeah, this is what we had. I had this like posted up in my in the driller cabin, and so I had to basically fill this information out. And one time I was doing code 23 hours. Dang! It's kind of addicting though. And you get that, what is that? The dopamine, like, yes, I did it, success kind of stuff. Oh, yeah, this is what the kind of math stuff that I did was I was just used to this. And it's just like that. We had to keep up with it. Like every 100 feet, you would have to redo your kill sheet. Yeah, this is the school I went to. That AIDC well sharp thing. I had to get my well control license. But I don't know. They don't have these. I think these are all just vertical ones though, because we don't. You know, they don't just drill down anymore. You drill down and then sideways. You go like 10,000 feet down and then 10,000 feet like horizontal. But I mean, I know I have a picture of the driller cabin, but then I'd have to go searching through all my pictures. Because I had one kind of like this, but these are only the vertical ones. Because you had to calculate your vertical and your horizontal. Yeah, this is what my stuff looked like. I was on a chair like this. But man, they don't have any of the updated kill sheets on here. Well, this is kind of... Oh, God. You can't even see that. But yeah, I don't know. It's different. We didn't have to use that kind of method, basically. I don't know. You had to calculate how much pressure you were putting on the hole, because if you weren't putting enough pressure on the hole, then you could get gas back. But different formations yield different pressures and gas. But so you'd have to hold the gas back so you don't blow up the rig. But you would also have to keep your mud weight, you know, as low as possible too, because if it's too heavy, then it'll start breaking into the formation, and your mud that you're pumping down hole will start leaking out into the formation. And if that happens, that also causes fracturing in the formation, so then you get even more gas back if you do that. And then you end up like it literally, like if you push too much fluid in, it'll all come back eventually. Like it's like a sponge down there. You start pushing it out, it starts leaking out, and then it'll return it back to you like way worse. So we had to like keep up with that all the time to make sure that we weren't putting too much pressure on the well and that we were putting enough pressure on the well. Write a function. And greatest common denominator. Recurrent. That implements this idea recursively. This function takes in 2 positive integers and returns 1 integer. Makes it easier to find the greatest. So this, okay, this is wanting me to do it recursively, so I have to do it like this. No, wait. Right. Yeah, I have to do it within itself. You want to know what question is that? What question is this? I have to use the trick that you're talking about, that includes thing, however you say that, but I have to do it in a recursion, where I have to reuse the function within itself. So I have to create a function that uses itself. One time I was doing code 23 hours. Yeah, I saw that. I saw when he said that. I don't know if you heard me. Oh, only one code? Oh, I didn't see that part though. Yeah. I mean, I was wondering. You want to know? Oh, yeah. Honestly, yeah. Was it something like super complicating? Elite code 1006. I don't even know. Is there a way to look that up? Clumsy factorial? Oh, look, I found it. Elite code 1006. Is this it? Clumsy factorial? The factorial of a positive integer is the product of all positive integers less than or equal to n, for example. The factorial 10 equals 10 times 9 times 8 times all the way to 1. We make a clumsy factorial using the integers in decreasing order by swapping out the multiply operation for a fixed rotation of operations with multiply, divide, add, and subtract in this order. Oh, wow, that's weird. For example, so 10 times 9 divided by 8 plus 7 take away 6 times 5. Why would you do that? After getting the question, my brain, for this you sacrifice sleep. Oh my god. Oh god. However, these operations are still applied using the usual order of operations, arithmetic. I don't even know what kind of coding is. So this is leet code. Is leet code like a type of? Is it kind of like how? Or what is leet code? Yeah, I guess it's like a different. Is it Python? No. LeetCode is an online platform for coding interview preparation. The platform provides coding and algorithmic problems intended for users to practice coding. Oh, okay. So this is just a... Okay, LeetCode has gained popularity among job seekers. Oh, okay. Well, what kind of... How do you know what kind of code it's using? I don't even know how to check. Is it... Because this class solution public... And yeah, this isn't Python, obviously. I don't know what this is. How do you know what it is? Down arrow? Oh, this is C++? Or are you telling me to... Constraints accepted. Oh, there. Okay, I see what you're saying now. It's right here. Wait, can you switch it to Python? Class solution object. Dude, I don't know this. I don't know. Define login. Dang, so you can change which one it's using? Dude, this is kind of cool. What? Wait, so you can solve this problem with any coding? This is kind of tripping me out. Do not get into it. Yeah, I probably shouldn't, honestly. I was just curious about it. I don't think I could probably... I don't think I could... I'm still trying to learn the basics. Yeah, I don't even understand how this is supposed to work. Same like me. Oh, yeah. No, I should... Yeah, I'm gonna get back to learning the basics, because I don't even think I could... I probably don't even know all the stuff to try to figure this out, honestly. Type in into... Yeah, I mean, I'd have to... I don't know. Well, it says medium. I don't know. But I'm like beginner. That's cool. I didn't know about that. Oh, here's the one that you gave me. But I have to figure out a way to use this in a factorial, so... Which this uses what you were talking about.
Your what?
But
Your pencil?
in order to turn it into... Or if recursion... Curious Sleep dies, yeah, for real.
Watch out, I get your pencil. How's your classes coming, my love?
It's going good. I'm getting help from people from like the other side of the world.
That's really cool.
Well, yeah, I don't know where this dude's from. The other dude went to sleep because he's, from Russia, and it was like 12 a.m. over there. But this dude, it's like 3 a.m. where he's at, and he's like, I need to go to sleep, but I can't. I'm like, oh, God.
You're speaking his language.
He said he was doing, he showed me, he said it's 3:51 a.m.
Oh, wow.
I was like, oh, my God. He's on Saturday already.
Oh, wow.
Yeah.
That's cool.
He's in the future.
Time travel.
Yeah, for real.
I love time travel.
Dude, he's on the other side of the world for sure. He said he was up for 23 hours working on the one code. He showed me which one it was too.
That's cool.
Because there's a website where you can go and practice coding and stuff, and even like job people will
he
use
showed you
it.
the website?
Huh? Yeah. It was
That's
Leak
awesome.
Code. Yeah, look.
Thanks, man. Is he on there right now?
Oh yeah. He's still awake. Yeah, this is the one he said he was stuck on he was on it for 23 hours.
Oh, wow.
Yeah, and he just curiosity.
Yeah.
He was like, I had to figure it out.
All right.
Oh, is that here predicting your code? Oh, this one. Yeah, I mean.
Oh. Time travel.
Yeah, this one, all I gotta do really is, I'm gonna use this formula. But all I need to do is reuse this. And...
Do you need help? Oh, you're doing it
kind of need to find a way to put it here, honestly.
Is that your outfit that you wore today?
Yeah.
You look cute.
Thank you.
Oh man, can I go back? Yeah.
You always styling and profiling.
Alright, so I need to make the loop within this. So I mean, I have a loop. I just need to reorder it. Time travel. This isn't complicating. It should be really easy. I already have this formula. I just need to.
I'm glad we had that conversation.
What if I do?
Yeah, you
if-
can use this for now.
Okay. Should I put it on now?
If you want to. I won't
If B does not equal that,
smell that.
then C equals B. B equals.
Where should I do it?
I'm gonna go get you stick
Where
it
should I
down
do it?
later.
then
Huh?
Where should I do it?
Return.
Oh,
Put
okay.
it under your armpits. Do you need instruction or help? She stinks now. She's official, almost teenager.
I think this is how it works. Actually, I think that's it. So instead, take the wall away, put an if, and then return that, and that'll send it back into a loop. I'm pretty sure that should work. Yeah. Yeah, see, that's what I was easy. I was like, I already got the formula. I just got to reword it. Yeah. Because all God dang it. How do you say that word again? Recur. Oh, where'd that word go? Now I can't even find the word. I was like a recursion or recursion. Yeah. Just so in order to use a recursion, all I have to do is put the function within the function in a loop. Yeah.
So I have a good feeling about the on-air talent thing.
What, the radio thing?
Yeah.
Trying to get on the radio?
Bro,
I need
my
no
voice
clippers.
projects easily. I know that how to talk.
Ah.
The shutting up part.
Yeah,
That's the
you're
hard
always
part.
yelling.
Well, I mean, I can project without even having to yell. So like, just imagine me on
you just yell.
I do talk. I know how to talk.
You're like, this isn't me yelling. I can get louder.
I can get louder.
I'm like, I know you can get louder, but you're already pretty loud.
Well, and it'd be really cool because I actually like one of the radio hosts that I'm hoping to get an interview with.
That would be pretty cool.
That would be pretty cool.
Sounds really difficult though. You gotta be like, I don't know. I feel like they're gonna hire someone that's like, you know, like someone that they know. Someone's.
I mean, it gotta be comfortable with working with them because they are the main talent.
They gotta not suck. Promise me that will live. Promise me that Liv will be there tomorrow. That live. Oh, the live. Yeah. I was. Oh God, Jesus, I almost went
They'll
down.
definitely be live
See
tomorrow.
Yeah, no, I started doing this every day. I have free time right now to do this. So I'm trying to commit into, like, I want to get this coding stuff down, like, really bad. So the only thing that sucks is a lot of people were watching me because I was playing video games. And now I've been doing this more. And so it's kind of like some people jump in. They're like, hey, you want to play a game? And I'm just like, I'm really trying to get this down, though, dude. I'm committed. I'm locked in. I want to start learning more code than just Python, because Python's the good intro one, but everybody keeps talking about the other ones. Hey, hey, hey.
outside, and she told me to throw a stick, and then I kind of hurt myself.
You hurt yourself?
Yes.
Doing what?
Throwing a stick.
Oh. Okay.
She outside?
Yeah, she's outside playing with the dogs.
I know. I told you. I was like, I didn't even know you went outside. That was like the first time I saw her outside yesterday.
Yeah.
And she's like, I come outside all the time.
She likes the yard.
Okay. And just
dogs
keep
like
at
the
it
yard
one at a
too.
time. Yeah. I mean, I get the free time, so I'm going to do it as much as I can do it while I have the free time.
Mama?
What the heck is this? Oh, we talking about some crazy loops. That's what we're talking about right now.
Girl, you will be fine. That is not Band-Aid work. You are so silly.
All right. Here we go. I'm locking in.
Locking in.
We just saw an example where we could have multiple recursive calls inside the body of a function. Perfectly fine. I want to show you a different example now in which we could have multiple base cases inside of a problem. And for this, I'm going to use another classic old problem called Fibonacci numbers. And here's the story behind Fibonacci. Leonardo of Pisa, also known as Fibonacci, posed the following challenge. He said, imagine I put a newborn pair of rabbits, one female, one male, in a pen or an enclosure. And I'm going to assume that rabbits mate at age 1 month, and that rabbits have a 1 month gestation period. That is, they produce a new pair. The female produces a new pair at the end of a month. He's also going to assume that rabbits never die, and that the female always produces one new pair, one male and one female, every month from its second month on. And Fibonacci wanted to know how many female rabbits are there at the end of 1 year. So let's do a little sort of simulation of this, and then we'll figure out how to actually solve it. So we start off with a pair of immature rabbits, a male and a female, first month. At the end of 1 month, they've matured. They can therefore mate, and at the end of the next month, they're still around, but they've produced offspring, another male and a female. At the end of the next month, the original pair have produced another pair of offspring, and the first pair of offspring have matured. And that means at the end of the next month, both sets of mature rabbits now produce offspring, and another one is matured. And that keeps happening as we start generating more rabbits and more rabbits and more rabbits until we're overrun with rabbits. Question is, could I model this to deduce how many female rabbits are there at the end of a year, 2 years, 5 years, and when will Australia completely get overwhelmed with rabbits, just to take an example of a place with too many rabbits. So, what does this say? I've got a little sequence here. In fact, they're known as the Fibonacci numbers, in which I have the following property. At the end of 1 month, I've got one female. At the end of the second month, I've also got one female, who's now pregnant. At the end of the third month, I got two females, one pregnant, one not. And in general, at n months, I've got however many females there were at the previous time, and I've also got however many females there were 2 months ago. Why? Because every female alive at month n-2 will have produced one new female at time in month n, and those can be added to the number that were alive in month n-1 to get the total that were alive in month n. So there's basically the definition of Fibonacci numbers. And how do I capture that in code? Well, here I've got two base cases. I've got how many females at time 0, how many females at time 1. And my recursive case, notice, involves two invocations of that function. One for n-1 and one for n-2. And if I want to turn that into code, there it is. I've got two base cases. I'm doing it in one test, but I'm saying if x is either equal to 0 or x is equal to 1, return 1. Otherwise, return fib of x minus 1 plus fib of x minus 2. And if I were to run that, I can see that I can actually compute Fibonacci. Given fib, I can check that my base cases work. Fib of 0 gives me 1. Fib of 1 gives me 1. And just to do a couple of trials, fib of 2 should give me the sum of those, and fib of 3 should give me the sum of those, and fib of 4 should give me the sum of those. And you can see, in fact, it is doing what I expected it would do. Here's a case where I've got two base cases of 4.
I don't really understand what this had to do with the rabbit thing, though. If x, if he enters a number, if x equals 0, 1, return 1, blah, blah. Else return fib x take away 1 plus x take away 2. So if x is 2, then it's 1 plus 0? And that'd be 1.
Fib of 3 should give me the sum of those, and fib of 4 should give me the sum of those. And you can see, in fact, it.
Why would I give it the sum of those? If you put 3 here, and it's not, okay, it's not these, so it's this. So fib is 3 take away 1 is 2, plus 3 take away 1 is 1. Oh, that's 3. I'm stupid. Okay, so 4. Oh yeah, I mean it's what? So it's just. Well, that's just, I don't know what this has to do with the rabbit thing. I'm so confused. If you put like 20, it's just it's all it is take away 3, really. Well, no, it's not actually. No, because you're taking a whole number, take away 1, take away 2. So if you put like something like 10, then it'd be 9 plus 8. 1 plus 1 equals 2. Yeah, I don't know what this has to do with the rabbit thing. I'm kind of confused. Like,
Is doing what I expected it would do. Here's a case where I've got two base cases, and in fact I kind of know I need it because my return here in the general case needs 2 different invocations of that function, and I need 2 base cases to make sure that I can settle that out. We just saw an example where we could have multiple recursive calls inside the body.
yeah, I don't really understand. I don't know. I get the rabbit thing, but like I don't. That was the thing for the rabbit thing? That didn't feel like the same.
We've seen a number of examples of recursive functions, something you're going to use a lot. But all of them so far have just been numerical. So let me show you one more example that I can do recursive.
Oh, wait.
problems.
Wait. I wasn't thinking correctly. Hold on. God dang it.
We just saw an example of 0 gives me 1.
No. I messed up. Wait, so you return you're returning its own function. So it's x take away 1. Oh no. It is like magical pattern. 2 plus 3 equals 5. Yeah, but like. Okay, no, I was thinking like the x and then you just, but this, if you put 10 here, then obviously it skips this, but it goes to else, and then you get another function where it's 10 take away 1 is 9, but that creates another function of 10 take away 1 equals 8. It's called what? But this is it's gonna return all those numbers right back, right? Like, man, this is. I don't know. This it's not simple. It's not. Hold on. I don't know why I had to use the small numbers. Like, I want to see, because the bigger the number gets, it's gonna start doing some weird stuff. Like, I don't know. Assumes x and whatever greater equal to 0 in case I come back and see this returns the Fibonacci effect. If x equals 0 or x equals 1, return 1, whatever else. Return But this is another one of those loop things. X, take away 2. Like 12. 233. Each new value builds on the previous 2. Balanced growth. It's because how he was talking every month, it's gonna multiply. So every time you, like, that was the thing with the rabbits, is like when you start with 1, and they'll make another one, but when you have like 5 rabbits, then your growth rate is going to increase because they're at a consistent growth rate. And so the bigger the number you put in, I mean, it's, so like if I put 50, it's going to be like a crazy higher number. Oh, what happened? Oh, God. FedEx, take away 2. That didn't work for some reason. Okay, Feb. Is that too big of a number? Oh, God. Jeez. I wonder if I can add some. So can I see how many times it's running through the sequence? Ah, screw it. I get what's happening. It's just kind of, it's like tripping me out because the bigger the number gets, the crazier this loop gets. It's kind of like, I don't know. That's crazy. I didn't see that at first, and it's not only doing that, but it's sending 2 loops that are just going and going for like. Oh, that just sounds crazy. Like, until it runs out. I mean, it's take away 1, take away 2, but try to print the series instead of adding. Print the series? How do you print the series? Because I know, like, the way he was showing how to do it is you can, do something like this. That's the only way I know, like, knowing how many times it's doing it is, like, count equals 0. And then I think if I do it like this, it'll tell me. Count equals +1. No. Yeah, I gotta define it. God dang it. Okay. Count equals 0 +1. Does that work? Okay. And then down here, I think this should work. Oh, but that only works within here. God dang it. Okay. There. Will it tell me? I don't even know if it will. So fib. Oh. Now it's just printing that. Ah, crap. $1.89. I don't know if that's working right. Print fib. Remove return and else. Oh, replace return with print. That still says 89. Hold on. I gotta do something like. And then. Delete. Okay, here. I'll try that. No, it still does 89. Oh, wait, no, that's the same. I gotta run it again. I don't know what that means. X takeaway one. Oh, fib. Are we talking about down here? I'm kind of confused now. Not gonna lie. I'll put it back so I don't forget it. Oh, dang it. Redo. Crap, what do you call this again? This is the Febon. Oh my god. That's a weird word. Save as. Let's see. is it saying invalid non-printable character? What character? Yeah. Full screen. Oh man, I don't know. Here's the other one, but this is equal to return print A. Function ends here. I don't know what this thing's talking about. Invalid syntax. Oh. God dang it. I can't send you image. Return print A is Is this what you were talking about? Not colony line. Oh. Well, it don't. Does that make a difference? Oh crap! What the heck is that? Oh no, I'm totally confused right now. Give input, like any input? That's like 3 numbers though. I have to put all 3 of those numbers now, right? B A plus B. I don't know what numbers to put. 8. Okay. Like that? No? I don't know, man. Leave print. Can I do it like this? I'll just ignore them.
Yeah, and I'm okay with that. Like, obviously, I'm not going to be everybody's cup of tea because I'm a particularly strong type.
Go. Okay, give me a second. Go give that to Cora. Ask Cora.
Now tell Dada. Dada, oh my God.
More juice?
Yes.
Miss Tracy was asking if,
Wait.
because she's already gotten on me, I take our birthdays off, right? My birthday, the kids' birthdays,
Oh.
Kevin's birthday.
Yeah,
Alright?
that's
I am available all day for their birthday.
yeah.
Okay? So, she already knows that I'm taking my birthday off, and she goes, yeah, but it's just a day.
Oh.
No, bitch, this is the day I graced the world with my
Yeah, it's still doing it. Okay, juice. I get it. I'm getting you juice. What? Your boots?
No, my dirt.
Dirt?
Yeah.
Okay.
Over something that has nothing to do with her. It's simply her opinion on it.
Yeah, just a day.
Understand?
Well, first off, if I pop my kids out, their birthday is not just a day. Period.
How was your drive?
Give her a choice. She can either take her birthday off or one of her kids' birthdays off, but not all of them. And I said, all right, well, here's my 2 weeks resignation.
Mm-hmm. Because I'm taking all of them off.
Yeah, I didn't do anything.
Alright.
Stutter didn't miss a beat. You can have my 2 weeks.
You telling me to pick one of my kids to take off their birthday? Are you fucking nuts?
I know that they're joking, okay? But that's how people start to, I don't know if you've ever noticed this, okay? But that's how people start to cross boundaries and lines drawn. It's how they get over your boundary before you even realize what's happening.
Oh yeah. This is just all hee hee ha ha.
Jokes about it, and then they'll think
Oh, that's better.
giggled or you didn't stand your ground, then there's wiggle room there.
Well, you know what? I'll probably do like.
How I deal with my shit, here's my 2 weeks. And I was so and I told Tracy I even take mine as a Christmas present.
It ran through it that many times. I found out a way to get it for n equals 5. That should be coming. For n equals 5. Oh. No, I'm confused. Are you? You're trying to make a loop, right? Hey, what's up? Peak Piece. Yeah, we're playing our own coding. Well, I was messing with this, and then let's see. Because there's a I was originally just recursion. Yeah, we're doing recursion. No, are you using Python? I don't know. Maybe I got it set up wrong or something. I don't know. No, yeah. Try 015.
Honestly.
Should I be printing it? I don't know.
Honestly.
I don't know what it's supposed to be doing.
Okay.
Let's see, X. No, wait.
Honestly. Mm-mm.
Oh, God.
Oh, yeah.
I was not expecting that. What the?
Honestly. which is which is which is interesting because in all honesty, you're not asking a lot.
I don't know what I
Taking
just
off
did.
your kid's birthday is not asking a lot. But if that's a thing, then okay, bye bye.
I don't know. Yeah, it was scrappy, and I will try to revise the language I learned from you after my exams. I mean, I could only hope. I'm trying to get good at it. The stuff's it gets confusing, and then I end up doing this crap where like I was doing stuff, like I was doing the classes, and then like I start getting like hooked on like seeing like, wait, can I make it do this? Can I make it do that? And then you just get lost in it. I don't know. I was like doing the classes, and then I was like, wait, I want to see if I can. I remember your name. I don't
Yeah.
remember which one. Were you on when I was doing the coding stuff? I've been going crazy on it lately, so I probably got this thing typed up wrong though. It's probably I don't know. I don't know what I did with this. If n equals 0, because it hasn't really been doing anything.
Jobs are out there.
But it can't. But I don't know.
Because I'm not it. That part.
Give me time. I mean, it's all good. It's whatever. Are you trying to work on this one? Or, well, nah, he already finished that. That one was crazy. I can't believe that one. That other
So
formula.
a couple of trials.
That
Fib
was
of
tripping
2
me out.
should give me the sum of those, and fib of 3 should give me the sum of those.
Alright. Alright, I'm gonna see what the next thing's at.
No.
The hardest part about coding for me is how to develop the logic on how am I going to do it. Yeah, it's crazy because like it's easy. It's definitely it's always easier to read the coding than it is to try to find a way to make it do what you want it to do. It's like a lot of the time, like when he's doing stuff and I see what he's doing and I'm like, yeah, I get how that works. That makes so much sense. But then when I'm trying to figure out how to like do it without knowing how to do it, like even though I have the resources, like that's the hard part. Is God, dude, hardcore brain activity.
Problem solving recursive functions on other things. For example, on strings.
Yeah.
So here's the challenge. How would I tell if a string of characters is a palindrome, meaning that it reads the same forwards and backwards? Now I'm going to cheat a little bit and remove punctuation and capitalization, but I just want to know, is something a palindrome? Probably one of the most famous, attributed to Napoleon, although I don't know that he said it in English.
Just filled up your juice. More juice? Jesus. Hey, she's staying hydrated. I haven't been giving her much juice. I've been giving her like a dab of juice and like all water. And she's been chugging it.
That's good.
She gonna pee a lot though. I've been like testing it. I've been like giving her like a little bit less apple juice every time. Sorry, I know you're on the phone. Oh, crap. These things get so blurry so easy.
Honestly. And or use you to step up on.
Oh, I was gonna water.
Yeah. Yeah, they never do. People don't want to see other people succeed. It's like a crab bucket. But then there are a mass amount of people that do want to see people succeed too. So. Those
Oh
are your
man.
people. Yeah. Those are your people.
God dang, y'all all from the other side of the world. It's like the middle of the day for me. It's 5 a.m. there. It's 5 p.m. here. Yeah, y'all are like literally on the other side. That's wild. Yeah, I could try it. Is that one that you had here?
Yeah, honestly.
Did you need to do it differently or something? Let's see here. ABN. A plus B. Oh, I see what you're doing. A plus B.
It's good though.
Zero.
You're feeling this today.
And take away 1. If n equals 0, then print. Okay, print outside the if. You think it'll be able to count it though? Print outside the if.
Yeah, they'll never understand.
Like on top of it? Well, if n is equal to 0, that's when you want to print it, right? Below. If return, like. Like just blow it like this or all the way off? Well, I mean, I guess if it's if, you have to put it in the if. Like that, right? Yeah, the 0 plus the 1 every time. These is 0.
Yeah.
And how many times I want to run it. Return 1.
Yeah.
If n equals 0, return 1. Return 1? Like that?
Yeah, honestly.
Fib and print backspace. Like that?
Yeah, you lose all the good.
All the good.
Oh, wait. Oh, right in the eye. Right.
3, 2, 1, 1, 0.
Hey, let me give you a holler right back. Love you. Hey.
Well, it gave me a return. It has no end. I mean, it ended. Oh, the 1 is the return one. And then 0 is once it hits 0. Series. Alright, does that show how many times it went through? Look at this number. series of Fibonacci. Is that how many times it actually runs through? Print should be upside down. Oh, print should be up. Above fib. Every number calls function itself in recursion. Oh. So these are the actual amount of times it like looped through. That is 50 and 100 is heavy. Yeah, because the return is 1. So that's the only number it's printing out. We'll print A. Then A was 0, but A plus B is 1. So we got print 1. That is a Y before it got stuck. Every number calls function itself in recursion. Addition of all those numbers is the code that you have written before. Told him, are you talking about this code? Oh, goal. Wait, so why doesn't 50 work for this? Because it's too high of a number or something? Because they're too heavy. It's 30. God. So it's that much calculation that it just like, it's just too much. Oh my God. I can't even do 40 because it multiplies so much. Okay. Try 32. I mean, it took a minute to do that one. Fib. 35. Oh, God dang. Okay, so it's still doing the calculation. Just do, well, I mean, I can do a 10, but like, I'm just like seeing how much it's slowing the computer down to, you know, I mean, how many calculations that is that it's going deep. Because look at this, if I do 36, it's doing so many loops that it slows my computer down by like that much. So every time I go up, it's getting like slower and slower because it's like so much. Jesus. Oh. So on this one, you can see what's... Oh, crap. My bad. Well, I mean, can I just... here. Yeah, but is this really doing that calculation if it's able to do it that fast? Because, I mean, that was the only thing with this one and this one. Well, this loops around once. But, I mean, this one's looping around like... I mean, it's got 2 loops going at the same time. Or I guess this adds the 2 loops like that. Is that how you did it? Because this one, when I run 50, it's like... I mean, I can't even run 40. Let's see. See how long it takes to run 40. Is my understanding helping? Yeah. I mean, it's a trip, dude. It's like, that's kind of crazy how just this small, like, God, that took forever. Jeez, it took so long to get back to me. God. It's like yelling down a well, just waiting for it. So you know how fast computers are. It's like, God. Extensive calculation. Okay. It's 5 a.m. I think you're supposed to go to sleep at 5 a.m. I don't know.
We've seen a number of examples of recursive functions, something you're going to use a lot. But all of them so far have just been numerical. So let me show you one more example that I can do recursive problem solving, recursive functions on other things. For example, on strings. So here's the challenge. How would I tell if a string of characters is a palindrome, meaning that it reads the same forwards and backwards? Now I'm going to cheat a little bit and remove punctuation and capitalization, but I just want to know, is something a palindrome? Probably one of the most famous, attributed to Napoleon, although I don't know that he said it in English, was able was I, ere I saw elbow. If you look at it frontwards or backwards, it reads out exactly the same. Second one, attributed to Anne Michaels. Are we not drawn onward, we few, drawn onward to a new era? And you can see if I read it from right to left or left to right, it's exactly the same. I'd like to write a piece of code that can solve this recursively. And you can think about doing it iteratively, but recursive is so...
Oh my God, that's a trip. Have you ever heard of that? Babe? Have you ever heard of that? Palindrome?
Palindrome, yeah.
Are we not drawn onward, we few drawn onward to new era? Wait, but it has onward twice. Put onward backward. That doesn't work. Well, it was able I was, ere I saw Elba. That one makes sense. But the other one, I mean, it's like kind of close, but the onward doesn't work, does it? No, wait, does it? Oh, drawn onward. Backwards is drawn onward. Oh, that is a trip. Oh, man. That's pretty weird. Never heard of such things. Hold on. How to do it on here? What is it? Yeah. Yeah, that's a...
much better a solution to use.
Reviver.
So how would I do it? Well, I'm going to do a little bit of cleanup first. I'm going to convert the string to just the characters. I'm going to strip out any punctuation, and I'm going to convert lowercase, or everything from uppercase down to lowercase. So I just have it all as a sequence of characters. And then I've got a very simple solution. If the string is empty, it's a palindrome. If it's just of length 1, it's a palindrome. Otherwise, how would I tell if some string is a palindrome? Well, check the first and last element. If they're the same, then check everything in between to see if it's a palindrome. That's cool. That's a recursive solution. I've just broken it into a simpler version of the same problem. And of course, as I keep breaking it down, eventually I'm going to get down to either a string of 0, if the whole thing started off as odd, or sorry, even, or a string of 1, if the whole thing started off with an odd length. Can I do that?
Can I
You bet.
Animal Crossing?
I'm simply going to write
Yes.
a little piece of code that's going to say, if I've got a piece of code that's called is it palindrome, I'll first convert this just into the string. I strip out all the separate spaces, the punctuation. I remove uppercase to lowercase. And then, as I said, if the first and last element are the same, then I just want to check, is that a palindrome? And there's the code,
So
nice and compact.
Hold on. Let me see.
this.
Table was I.
Then I just want to check,
Okay. Put that in there because tomorrow I have to leave to.
is that a palindrome? And there's the code.
Do my background check tomorrow.
Oh, for your thing?
Yeah.
Thingamabobs?
You have the license.
Oh, yeah. The escrow license? I'm gonna be an office worker.
So if I don't get the talk show job,
Right.
honestly, I would prefer the talk show job, but I'm not opposed to sitting down in an office somewhere doing escrow. And there's a lot of remote jobs online, so I could always just use my office, and then it'll pay for itself. And then at least a job with 40,000 or more a year and be comfortable. Ish. That would give you that sense of security.
Oh.
Security. Be interesting to get an escrow job though. Or anything, the only thing that's really gonna cost is the background check, but that lasts up to 5 years, so
What?
background check.
It could take up to 5 years?
No, it lasts. It's good for 5 years.
Oh.
TSA background check.
Yeah. Let's see. Yeah, you do need sleep. I can't believe you stayed up this late. That's crazy.
Mama, are you okay with Drago leaving?
What?
Do you want Drago to leave?
No, I don't want Drago to leave.
Okay.
How many times are you gonna ask that? You're trying to
So
get
the-
rid of Draco like every time.
That was the rhino
Our
last
favorite
time.
ones.
Rhino's not the rhino.
I know, but the
I was
Drago and
asking
the
if
other
you
one.
want them to leave.
And Spike.
I'm
And
getting-
Spike, yeah,
I'm
she
getting
keeps
an
asking if we
opinion.
want Spike to
I'm
leave.
asking if they want them to leave.
Well, she's trying to get rid of them.
I'm not. I'm just asking.
Spike is like, hey guys, Cora, she said she don't like me, so. Alright, let's see what it says.
Let me see.
It didn't return anything. What? I need to sleep. Should I go? I don't know. Oh my god.
Get some sleep.
I mean, you should probably get some. I mean, do you have to do anything? Like. Oh, why don't I get anything in return? Return is pal to.
Nice and compact, nice and simple.
I mean, he didn't put.
I'm not going to
anything.
walk through all of it, but you can see the first part here is simply something that's going to convert that string into characters. It takes advantage of a property of strings that I can call a method called lower that will convert everything into lowercase. And then I've just got a nice little iterative loop here that basically walks through each character in the string. There's that iteration over the string itself. It's a string iteration. And it basically says if that character is, in fact, a character, add it in. And then there's that nice, elegant solution to palindromes. It says give them one of those strings. If it's of length 0 or less, if it's of length 1 or less, it is a palindrome, return true. Otherwise, check the first and last. There's that call with -1 to a string, the first and last character of the string. And check by slicing out from the string everything but the first and last character and see if that's true. And finally, I'll just convert the string and call isPal on it. Let's try it out. I've got those two characterizations over here. I've got it loaded up, and if I call it, it says, is, for example, a simple thing like Eve a palindrome? You bet, EV.
Oh yeah, see, he actually put. Stop. Hold on. What is this? Print.
E is a palindrome. And what about is able, was I, ere I saw Elba, a palindrome? You bet.
Oh, there it is. Okay. I was like, man, he didn't even set it up to where it printed it.
I don't think it should be that much, should it? What are we having for dinner?
What do you want? Later, man. Dinner. What should we have for dinner? Let me see. Corey, hungry? We still have those chicken tenders.
We do mashed potatoes and corn.
Yeah. We can make the famous bowl with the cone and the mashed potatoes and the brown gravy and the chicken strips. Bada bing, bada boom. That's a famous bowl from KFC.
Did I hear ravioli? Or did I
Yeah,
not?
but she won't eat mashed potatoes. Do you eat mashed potatoes now, finally?
I mean, I like them, but I don't love them.
We can
I don't
give
really
it
like 'em.
to all separated, and then we can make a famous bowl for us.
Yeah.
I think I might have heard ravioli. I don't know.
We didn't say ravioli.
Oh.
We eat pasta all the time. Yeah, we can make it all separate. You wanna do that?
Okay.
Am I doing it? I need to know if I gotta shut it.
Yes, you're shutting it down. I'm sorry. I hate to
Okay.
do this to you.
You hate to do this to me, but you're doing it to me. It's returning on. It's not working. I have to come back to this. Alright, everybody's gone anyways.